Can you see if we can see it properly?
Yeah,
Thank you, Harshal. So in order for a lender to approve it, and if you're like it's performing the test, there has to be a credit application in the system. That means you need to know how to submit a credit application. Well, in order to submit a credit application, who can submit that? Only the dealer users. So now you need to understand how you can create a dealer user account in the system to get into it. You see how all those pieces are connected? Even though you're trying to perform this small testing, you need to worry about how you're going to set up that data or set up that environment. Right? Versus when you think about a developer's roles, once the system architecture is defined, they essentially focus on one specific area only, depending on the size and scope of the system. So therefore, a lot of times you will find that the quality assurance person has a much better understanding of what the system capability is, what are the issues, what are the features implemented into the system, much better than the developers individually. Okay. Also, part of it is, we talked about the various different architectures, right? And part of the reason why we talked about architectures you want to understand is what are the integration points for each one of the components? Because most likely when a failure occurs, it is going to be much more likely that it's going to be on those integration points. So in order to do that, you need to understand how the different functionality is implemented. So when you look into the RFlow, and when we looked at the design document, it had like it's only 5 components that was implemented. Remember, security manager, and then the credit application and reporting and that. You need to have an understanding of all those components and functionality of what each component does it in order to perform the testing. And then you can identify, hey, the handoff is happening from this component to this component, and most likely it's going to be written by 2 different developers, and they may have a different understanding, and I need to make sure that they integrate well with each other. Okay. Obviously, we talked about the test cases, and then the way you want to focus on writing the test cases is that it's very likely that it can uncover an error. Okay. Now let's talk about what exactly you do it as a software tester, right? And remember the term I'm using, it's a tester at this time. And when you take it, you're going to focus only on the testing point of view, right? But there are certain aspects, as I said, that you can start doing testing sooner. So you can start becoming from a tester to quality assurance person. So we looked at the software development lifecycle, right? SDLC. You're going to find a term, something similar for the testing world, and it's known as testing lifecycle. Okay. So you will see a lot of commonalities between this and the software, somewhat to the software testing lifecycle. Okay. So the first thing you're going to go into is identifying the requirements. So this is the analysis phase. When you're looking at the requirements, you want to make sure that it meets all the 3 C and T conditions. So understanding it, what things needs to be tested, what are the feature and capability of the system is going to be the first step. Because without knowing that, you can't write what you need to test it. Then you're going to look into building something known as an acceptance criteria. So if somebody gives you a requirement, so if I come to you and this says, hey, we need to make sure that the electricity is working fine in this room, right? So that's my requirement. So first thing you need to think about it is, how do I know electricity is working fine, right? What is the definition of that, hey, this thing is working? So in other words, what is the minimum thing I will accept it that identifies that this thing is working, right? And one of the ways you can do it is, hey, if I turn on this switch, make sure all these lights are turned on. If any one of them doesn't turn on, then there is a problem. So now I did identify it. What is I'm going to accept it as the passing criteria. Okay. So as you go through it, understand every requirement, you need to say, what is the criteria I'm going to use it to make sure that that particular requirement is met? Okay. Then, once I understand that, I'm going to go into the planning phase. That means, hey, in order to do those requirements and in order to meet those acceptance criteria, what all tasks I need to do it, what all test cases I need to build it, how I'm going to approach it. Okay, so that's essentially your planning phase. Then you get into the design. So once I know what all things I need to test it, I can start writing step-by-step instruction. So in other words, hey, I'm going to test that every light works. Well, I'm going to walk to the switch, I'm going to turn on, and then make sure all the lights are valid. Then I'm going to turn off and make sure everything is turned off. Those are step-by-step instructions. That's what I'm going to do it. So that becomes part of my design phase. Once I've written step-by-step instructions and the room is ready for me to do testing, then I'll go ahead and execute those things, right? I'll perform those step-by-step instructions. And if I need to change my instruction based on what I learned it on the construction of the room, I'll go ahead and do that, right? So when I perform the actual testing, that's an executing. So a lot of times when people focus only on testing, they just focus only on this two parts, right? But you can't effectively do this unless you know this two part, right? And then once I start executing it, the chances that, what is a good test case? That I'll find an error. So if I find an error, then I need to tell somebody in the development team that, hey, this is the error. You go and fix this. And they said, okay, we'll go and fix it. Once they fix it, they give you a new version of software that you will rerun the testing, right? So you will re-execute testings, and then you validate whether it fixed or not. So you will go back and forth on this entire phase till all of the defects are fixed, or your business user said, okay, I can accept with this certain defects. All the other ones are okay. Okay, so that's the defect tracking and bug fixing. The next phase that comes in is review and audit. So once I'm done with all of the testing, I need to go back and reflect it and say, did I have all the acceptance criteria tested? And the way I know by is all the test cases that I wrote it, are they all passed? And if that's the case, then I can verify that all the requirements for which acceptance criteria and test case were written are passed. And then at that point, you can say, hey, is the system now ready? Send it to the user for testing. And if it is, then you accept it and create a baseline of the version and says, now this version of the software is ready to be shipped. Okay. And then you go back into, as the new features comes in, you follow the cycle again. Okay. Any questions? Do you understand it? How those things flow? Okay. So one of the other type of model that you're going to see is a V model. Okay. So in this model, if you think about it, you essentially go down this path for designing it, your test scenarios and test cases. And then you go down this path when you're ready with the system for executing. So now let's talk about it, what it means. Okay. So this is, if you think about it, this is a more or less kind of a different view to see the software testing lifecycle. Okay. It performs the similar activities, but it goes into a different mindset from what we call it is from top-down approach to take a requirement, drill it down till you write the code, and then test it back going up the chain. So think of it, whenever you get a requirement, you need to find it, hey, how I'm going to validate it. If I got a requirement A, I need to make sure I have an acceptance criteria XYZ that validates it. And a lot of times, those acceptance criteria are nothing but from a user's point of view, because I don't know how the system will be built at this point, right? So all it just says, if I'm a user, how would I test this requirement? So a lot of times that term that used is user acceptance testing. So just by knowing the requirements, I will just go ahead and write the acceptance test cases from the user's point of view, because I don't know how the system is built, right? So let's take an example. If I tell you, by giving an e-commerce website and says, hey, can you test it, see if you can order a certain thing from this site? Do you really need to know how the system is implemented? Most likely not, right? All you're going to say, hey, let me just follow the screen and whatever the prompt that it does it to perform, whether I can do this task or not. I really don't care whether it's implemented in one platform or in a completely different platform. So having that user requirement, you start building what is known as user acceptance test cases. You still don't have any software at this point, but you can still write those design of those things. Now, the first thing that happens is when you get the requirements from a developer point of view, is you take it and says, let me break it down this into functional specifications. So think about a design document. Right? So you had a requirements document which was written from a user's point of view. I'm taking that and converting it, says, okay, in order to do this, system has to be built with this specifications, right? So if I just say, hey, I want to build a 2-story house, right? That's my requirements. But the constructor essentially takes it and breaks it down, said, in order to do that, I need to build a foundation, then I need to build a frame, then I need to do this and that, right? So they will identify the specification. Well, since it's 2-story building, how would it take me to go ahead and build the foundation? What kind of strengths I needed, how deep I needed, how thick each one of the pillar needs to be that supports the flooring, right? So that's nothing but a functional specification. You do the same thing from a system point of view. In order to build it, our flow, think about it, it says, hey, I needed 5 different components. And in each component will perform these tasks. So that's a lot of times you think about it as I'm taking the system view and breaking what are the different components of systems are going to be. So as soon as you build a specification, you can start writing what is known as the system level test. How I'm going to write, not individual component, because it's individual components are not written yet. But the system is defined, how those interaction is going to be defined for it to meet the requirements that were specified by users. So you go one level down. Now you have some knowledge of how the system is built. And the development team working with the quality assurance person will start writing what is known as system level testing. Okay. Then once the functional specification is defined, you go down one more level down and says, okay, since there are 5 components, now let's look into each one of those 5 components. And let's start talking about how each component is going to behave. What are the characteristics? What is going to happen? And in order to write those functional specification of each individual component, you write the test. How would I know that security manager is working? Well, security manager will get the user ID and a password. It needs to go validate it, what kind of user this is, and make sure you can give it only that home page, right? So you flag it that, hey, now go display this page. Those kind of details and the testing, you write it down here. Okay, so look at this. Still, I don't have the code. All I have it is going it down into further and further detail of how the system will be implemented. The next step comes in is I take that module or the component that I talked about, security manager, and I may implement into 5 different what is known as programs. Okay, so the way the structure of software development happens is you don't have one big monolithic thing. Everything is broken down into small pieces, and each piece has its own input, output, and functionality that gets implemented. And when you combine all of that, then it becomes a component, and then we combine all the component, it becomes a system. So at this point, now I'm going into writing every specific detail. Hey, this is the function, and the role of this function is to take this type of input, perform this kind of processing, and provide this kind of output. So I'm going at lowest level of the detail. And in order to validate that, is it working or not, they write it what is known as a unit test. And quite often it's the developers who write the unit test because they know every small detail of this. Okay, so if you look at it as a quality assurance person, you were engaged in the first 3 types of testing, but you're completely disengaged from that because this is now the lowest level of detail that the programmer is going to validate whether this thing is working or not. And once I have that level of detail given to the programmer, they can say, oh, now I can go and implement this thing. So they start writing the code or implementation phase of that. Okay. So this is all kind of planning aspects. As I go through it, drilling it down, I'm writing more and more level refinement. Once the code is ready, I'm going to go ahead and start executing everything that I have built it as my test scenarios and test cases. Okay, so code is ready. I'm going to pick up the unit test and validate it. Okay, if it doesn't pass, I'm going to fix the code and come back. I'm going to go this loop till I pass it. Once I pass this thing, now I have individual programs ready and they are tested. Right. Next step is just think about Lego, right? You have each individual components ready. Now I'm bringing those together to form the structure. And the first structure is my component, right? So if the component is made of 5 programs, I'm going to go ahead and test all of that, make sure everything works as a single component. So now, not individual functions within Security Manager, but is the Security Manager working together as a one piece? That's what the link test is going to validate it. Yes?
So on the bottom where you said for the unit test, that's where the developer creates the unit test cases.
Right.
And when you say when you're going up, that's when the tester is going to start. So is the tester picking the unit test cases, or is the tester creating it?
No. So we will talk further more a little bit later, but this is the lowest level. This requires you not only just the knowledge of functionality, but the knowledge of software development systems, right? So programming languages. So typically all this thing work is done by the developer. So developer writes it, and then they test it and validate. In the olden days, right, the mindset was, I'm going to write the code first, and then I'm going to write a test to test that code, which is always flawed, right? So now in the modern engineering practices, they start doing what is known as the test-driven development. So they actually write the test first. Make sure those tests are failing it because there's no code to back it up. And then they write the code and then they test it to make sure that did it pass the things that was failing earlier, because now I have put it down. Okay, so a little bit later in the module, when Herschel talks about the more modern ways of testing, we will talk about that thing of how to do the test-driven development. Okay, but think about it this way: it's irrespective whether you're doing a test-driven development or you're writing code and then performing testing, you need to know what I'm writing, right? So for example, if I'm doing 2 + 2 and I'm writing a calculator program, I need to know, hey, I have to provide 2 inputs, an operator, and then what kind of results I will get that, right? So that's what this segment is. The still developer, because they have an in-depth knowledge of exactly how each of the program works. Okay. Because remember, when you're testing it from the requirements point of view, you don't care how many programs are implemented. You care, is it working together as a one function? And that first scenario starts coming in from here, because you are like, it's knowing what are the different components are, and what functionality of each component is good. So that's where the link test comes in. Once those passes, then you go into the other things. Now that I have each one of the 5 components working individually, I'm going to bring all of them and says, now do they work cohesively as one system? And that's what the system tests are going to be. Okay. And then once everything is working together as a system, remember we talked about from a user's point of view, hey, I'm going to validate all those acceptance criteria that I wrote it without even knowing the details of how the system is implemented. They're going to run that and say, is it going to meet my conditions? So when you think about it from a timeline point of view, while I'm traversing down, I'm writing it all those things. When I'm done with the coding and I'm traversing up, I'm executing and validating it that it does meet those things that I kind of put together as the design plans. Okay. If you look at it, same thing you were doing it here, right? But what we did it is we took this 2 things and says how this thing is going to be broken down further. And that's what you're going to see it here. Okay. Any questions on the V model? Okay. So now that you have conceptual understanding of what happens in the test plan, let's talk about what do I do as a software quality assurance person or test lead role that you will see it. Okay. So remember, you got a requirements document, and the developer started putting together a design document with the intention of it, hey, I need to know how I'm going to implement it. Okay. You need to start putting together a plan as a quality assurance person. From those 2 documents, says, I need to know how I'm going to test this thing. How much effort it's going to do, who is going to do what task, and how long it's going to take me, right? And part of the reason why you still need to know that is, remember, everything costs money. So the project manager needs to know the information from a developer, how long it's going to take it to build it, and from a quality assurance team is how long it's going to take you to test this thing. I need to put both of this together and then give a single view to my customers that this is how long it's going to take it to build a system, and this is how much it's going to cost. Okay. So in order to do that, you as a quality assurance person associate with something known as a test plan. Now, if it's a big system where multiple people are engaged in performing testing functionality, typically this test plan is written by whoever is the lead tester or lead quality assurance person is. Okay, and it's written only 1 per system. So not every tester is writing that individual, it's just 1 person making sure there is a comprehensive view of how the actual system is going to be tested. Now, if it's a small system and you are the only quality assurance person, then obviously you're going to write that. Okay. Typically, there are already templates at the corporation level and says, hey, in order to do the testing and perform a test functionality for validating a system works as expected or not, here are the minimum things that you need to specify. Okay, so let's look at it at a high level. What are all those things that contains it? What is the mindset that you need to know in order to come up with an estimate of how long it's going to take me to build the system? I'm sorry, to test the system that is being built. Okay, so you write it something known as a test plan. And the goal for that test plan is to first make sure from a quality assurance person's point of view, I need to know what all tasks I need to perform in order to validate the system, right? It's essentially a set of testing tasks. Second thing I need to know is if there are a lot of tasks, who is going to perform what function or what task? Okay. Then how long it's going to take me each one of them. Right. and what standards I'm going to follow while I'm performing this task. So let's go back to the house example. If I'm building a house, that house needs to be tested, right? So when you look into the county specify that while you're building the house, it must pass this test, this test, this test, and this test, right? So they are like, it's providing you the detail. Hey, it needs to get a structural test, which you want to make sure the house is going to withstand the wear and tear. It's going to withstand the environment that it's going to build in it. For example, like if it's kind of built here, they're going to make sure, hey, is it going to survive into freezing cold? Or is it going to crumble because of the material is going to start developing cracks because of the cold? Same thing with the rain and those kind of things. Then they start thinking about, hey, what kind of plumbing it needs to have it. There needs to be a plumbing test. There needs to be electrical test, right? And then there will be a final test when everything is built in. So they are nothing, but they are building it out. Hey, what are the set of testing tasks going to be? Then for each one of those inspections, they're going to identify who is the expert. From a county point of view, they are performing those testing and making sure, because everything has to comply with certain type of code, right? So that is a mindset of assigning resources that who's going to perform what. Then you're going to take it, how long it's going to take it. Is it going to take you to 1 day to do the test, testing? Or is it going to take you 5 days? Well, let's put together that, hey, you're going to perform this task, it's going to take this much time. Well, why do you need a time? For 2 reasons, right? You need to make sure you are able to build a timeline of how you're going to support that. And second thing is you need to understand how much it's going to cost to perform that testing. Right? So whoever the engineer is coming, they have certain costs associated in terms of salary and all those things. And you have to it's going to say, hey, if it's going to take you $100 an hour, and it's going to take you 5 hours to test it, well, you need to budget $500 for that testing, right? So you build all of those, and obviously documenting the testing standards. So there's always going to say, hey, which code, which compliant version, because things get updated every so often. So they're going to just say, hey, this is what the standard that you need to do it. So same thing in computer software testing. You need to break it down and perform all those things. And essentially, we talked about who creates it, right? And the whole goal for this thing is that validate the acceptability of the software product. Is it going to meet what I'm looking for? Okay, now let's talk about at a high level, well, what does it look like? What all it will contain? Okay, so the first thing it should talk about is the scope. Well, we talked about the various different requirements, functional and non-functional requirements. So Harshal mentioned that hey, for certain non-functional requirements, there's going to be dedicated teams which may perform. And later on, when we will talk different types of testing, we'll see there are certain types of testing, which is nice to have it, but an expensive test, and not necessarily it's going to be performed for every system, right? So the whole purpose of the scope segment within the test plan tells you what is the scope of this testing. Is it just the functional testing? Is it functional and non-functional both? If it's non-functional, what extent of non-functional? It's going to be a lower performance regression. What kind of testing are you going to perform? Okay. Second thing is going to be approach. So what kind of approach are you going to take it? Is it going to be part of the agile team so that you're doing an incremental testing as you're going along? Or is it a waterfall where, hey, I'm going to wait until all the software is done building it, then I'm going to test it. What happens when I find the error? How the error handling is going to happen, how I'm going to retest it, right? So all those things comes into approach. Then it's resources. Resources you can break it down into 2 different components. One is human resources, and the other one is computer resources. Human resources will talk about how many people I needed with this particular skills to perform this testing. And then computer resources talks about hey, how many machines I needed, what software I needed, right? So those kind of things goes into the resources. And then finally, schedule talks about the timeline, how long it's going to take me. Do I need it 1 week? Or do I need it 10 weeks? Do I need it like 3 months to test it? What exactly the schedule looks like. Then it can also go into the detail of what are the test items. So in other words, what are the tasks or features and functionality I'm going to test it? What are the different testing tasks? How those tasks are going to be allocated? Because if I have like 5 testers, well, who is going to perform testing of what feature and functions? And one of the important path comes into test plan is also risk contingency. So typically, let's say if you say, I want last 2 weeks of the system development to make sure that I have an opportunity to thoroughly test the entire system. It's a great thing. And they said, okay, so based on this, here is the date that we will release this product to the customers. What happens is if your development is not ready by the date that you specify, and the business comes and says you cannot skip the date because we already committed and there's a lot of financial implication if you don't meet that date. Well, that's a risk now, right? You don't have a product that you can thoroughly test it as you were planned for it. How are we going to deal with that risk? Right? So the plan to deal with those kind of risk can be in contingency planning. The other thing is they said, hey, you're going to get it, this kind of hardware installed and configured and ready for you by this date. You don't have a hardware. Well, how are you going to deal with that? Right? So you go ahead and like it's defined the various risk and contingency, how you're going to perform and deal with that. You also talk about the tools that you will need it. Remember in the resources, we talked about the non-human resources, compute resources. Well, what all I needed? Because certain things may be open source, great, doesn't cost you much. But if there are some proprietary softwares that you have to purchase, get the license, and then everything is going to be cost. So that's why I need it. Then it also talks about the deliverables. Okay. So it's not like somebody says that, hey, I'm going to build a system, and you said it's going to take us 8 months to build it. They said, okay, I'm going to like it just go in, give you 8 months, and at the end of 8 months, I'm going to show up at your door and ask it, is it ready or not? Okay. It's very risky. What they wanted is keep telling me along the way, are you still going to meet that deadline? Are you still going to fulfill the commitment that you're able to do that? Or anything changed it? Right? So let's take an example, right? So if I'm building a house, it's great. The contractor gave me, hey, it will be ready in 3 months, right? 1 month down the road, there's a torrential heavy rain keeps coming in for 3 weeks. Well, they couldn't build it during that 3 weeks. But if I waited only at the end of 3 months and said, hey, is my house ready? Right? I'm ready to come up with all the movers and everything and see if the house is not ready, right? That's a disaster. The better option would be is the builder keeps me up to date and say, hey, because of this thing, we can't meet this. So now the new moving date will be this or that. Same thing in this world, as you're going through the development, you keep providing an update that this is how I'm progressing it, so that you have a confidence that, am I going to meet that commitment? Okay. It's a lot more easier when you think about agile world, right? Because it's every 2 weeks iteration. So every 2 weeks, you're providing them an update, hey, I'm done with this much functionality. Okay. So if you think about this world, right? As you're building this test, you're making a progress. You can provide an update. Hey, I'm done with writing all the UATs. I'm done with writing this. So they know, hey, as I progress it, all this work is being done. So I will be ready to test whenever it becomes available. Right. So giving an update of how far you are in terms of writing and planning this test, it's a way to give your client a good indication as whether you're making a progress or not in a time management. So that's another aspect. Now we'll talk about some of the reports that you created as part of the testing. Okay. Then the last segment, right, we talked about, it contains the documentation standards. Well, what does those comes in terms of standards, right? So it talks about, here's the way I'm going to test it. Here are the templates, because I'm writing all the test cases, right? So what are the templates I'm going to follow for each one of the test cases? It also, more importantly, identifies the entire plan is based on which requirements document and which system specification document. Because remember, your entire planning was based on certain information that you have it. If that information changes, you may have to reevaluate the plan and update it to make sure that it reflects the new realities. Okay, that's why it's important that you identify, hey, this test plan was built to support the version 1.2 requirements document and 1.5 of the system design document. So there is a baseline that you created, it's what everything is based on. Okay. So now let's talk about a little bit more on the specific tasks. Okay. So there are two terms that you need to know. One is test scenario, and the one is test case. Okay. So test scenario revolves mainly around function. Okay. So a lot of time people will just say, it's, hey, what is the capability that you're testing? It is more or less going to be tied to the scenario. And then that capability may have a different path within that. And if you're like it's validating each of the path, that becomes a test case. So let's take an example. If I'm like it's testing system like Amazon, right? And they said, hey, I'm going to perform a checkout function. Right? That will be a scenario. Scenario is a checkout. I could have multiple test cases within that. And checkout says, hey, I'm going to perform a checkout using Amazon gift card. Or I'm going to perform a checkout using the existing credit that I may have with on my account. Another case could be is, hey, I'm going to give you my credit card to do that. The fourth one would be, hey, I'm going to provide some sort of payment gateway like PayPal to provide you the payment information. It's still the checkout function, but the different aspects within that, different test cases that it's going to validate each of the different components. Then I can say, now the checkout is complete because checkout indicated as a requirement that it should be able to accept one of these 4 types of payments. Well, I validated each of the payments can be successfully accepted. That's a scenario of test cases, right? It's a set of condition and a reach determines. Right? Another one could be is, hey, I'm performing a checkout, but I don't have sufficient balance. Right? That's a negative test case to say I should not be able to perform a checkout. Or I may not have a shipping address. Well, I can't perform. So think about those kind of scenarios. Then once I have scenario and I have the different paths, then I'm going to, for each path, I'm going to write the test script. And test scripts typically are nothing but a step-by-step instruction. How I'm going to perform this testing in a step-by-step format. Okay. Any questions on those 3 types? Because that's the fundamental, that everything else that we will do, it's going to rely on those 3 things. Okay. So test plan talks about all this information at a high level to do that. Then It also talks about the metrics. And there are two different types of metrics. One is product metric and the other one is process metrics. Okay. So think about it at any time you're performing some sort of work, right? You look into two different aspects of that work performance. One is how good the work is in terms of quality point of view, right? And second one is how effective the work is, which is a process point of view. Okay. So let's take an example. We talked about the search, remember, on the first day that, hey, I'm stacking up all the books and I'm searching through that. If I'm performing that work, there are two aspects I need to do it. One is, from a process point of view, is, hey, am I going sequentially or I'm just scanning it and says, oh, this file doesn't need, oh, you know what, but I forgot to test this, so I'm going to go back and do that, right? That's a process aspect. Am I effective in terms of searching through that stack? Another aspect is how effective my search is. So when I'm going through it, that entire stack, am I able to successfully say with a reliability every time that the book that I'm looking for is either in that stack or not in that stack? So in other words, am I getting a result? But if I go through halfway the stack and then restart from the top again because somebody added another book in that stack, right? It's not going to be very effective, right? So same way, like it's from a testing point of view, you build it into the product metrics and process metrics. Product metrics tells it how good is the product that I'm testing. Okay, one way it is, hey, I'm running 500 test cases and I found 400 defects. It's a very defective product, right? Because every test case that I'm touching, something is broken. They have not done a good job in terms of building it. It's much more easier for me to find any effects. And the process point of view is, hey, how long it's taking me to run those 500 test cases? Okay. And how many times I have to repeat those test cases because I couldn't get the conclusive result. Now that gives you an effectiveness of how effective my process of writing the test cases and testing it. Okay. We talked about the test case contains step-by-step instructions, right? It also contains what are going to be my input. Okay, so if I'm testing a calculator, right, it says, hey, what do you need in input? Well, I needed at least 2 different numbers and an operator that I'm going to perform operation on. Okay. It also asks you sets of execution condition for a test item. So sometimes this also refers as a precondition or an environment under which you're conducting this test. So if I'm performing the calculation, in this, is it starting a fresh calculation? Or I already pre-calculated certain things and then I'm taking it next step into it, right? So if I'm doing a sum and I already added 5 numbers and then I'm adding another number, my pre-environment was, hey, I already have calculated some of those things and I'm adding the 6th number to it. Right? That's the precondition. Same way in the testing world, right? When you're trying to approve or reject it, hey, you may have a precondition that it needs to exist, right? Credit application has to be in the system. Then only I can either approve or reject. If there is no such credit applications, can I do anything? I can't, right? So every test case contains the set of the condition under which you are performing this test. And then it also talks about expected behavior. So if I give the calculator software a 2 + 2, and there is no pre-calculation was happening. So that's my input. My condition is I'm starting fresh. my expected behavior, I should get a 4. So my test case clearly identifies, hey, if I perform this input under this condition, what should I expect to see? And then you compare them, hey, when I actually run the test, did I get what I was expecting? If not, then something went wrong. Right? It's either in my expectation something was wrong, or in the software which actually was built, something is wrong in that software. In a good test case we talked about is high probability of finding a new defect. The other 2 condition is also important. You not only want to have a test case that is able to find bug, but you also want to make sure that that particular test case provides an unambiguous result. That means it gives you a specific answer that you can compare it and give an answer. Did the test case pass or did it fail? Yes or no? As simple as that. If the answer is maybe, well, then maybe is not going to help because you don't know whether the system works as expected or not. Right? So make sure everything that you write it produces you a clear-cut answer. Did it meet or it didn't meet? Going back to 3C and the T condition. Remember, like as I said, it has not only the requirement has to be complete, consistent, and correct, but you should be able to test it also. If you can't test it, having those 3C is not going to be useful. Okay, same scenario. Make sure every test case that you write it gets you some result that you can inspect it. And another characteristic of test case is that it should be able to repeat it. By that, what I mean is, if I kind of start a calculator, and every time I do 2 plus 2, and the precondition of the environment is clear, then I should get every time the result 4. If it gives once, it gives 4, the other time it gives 3, other time it gives 8, it's probably not going to be a good test case. Right? Or it's not going to be a good system. Right? It has to be one of the 2. And if you're not changing anything in the system, right, then it has to be a test case. So make sure that every test case you write it is repeatable and it's predictable. That if I run this test case 1,000 times under the same condition and the same inputs, all 1,000 times it should get me the exact same results. Okay. Then it comes about test standards. Okay. Now, if you look at it carefully, right, when people talk about things in a computer world, they talk either computer engineering or they talk about computer science. Okay. There's a key difference between the term engineering and the science. Engineering is well-defined, predicted, and I know exactly what standards and everything will form exact same thing. That's an engineering. So if you look into the hardware is kind of manufactured, all of that segment is engineering. It's always predictable, it's always consistent. Versus computer science. Science is just nothing but a hypothesis, right? I'm going to predict it, I'm going to put this hypothesis, I'm going to put this experimental steps, and I'm expecting these results. You can always create a standard around engineering. You can create only guidelines around the science. Okay. Take an example, right? So somebody performing a research on a drug, right? That's a science. But the data of how you collect that information and you present it, it's a much more predictive, right? It's kind of exact analysis. Hey, when you say, hey, drug is 50% effective. Well, what is that 50% effective mean, right? There is a set of standards which tells you if you do this, and you do this, and you compute the effectiveness, then it gets at that. So you have to make sure that you understand the difference between a science and engineering. Software development is still a science to some extent. Okay. And the reason why it's science is no two software systems that you build it are performing exact same way. Each one has a different capacity and characteristics and capability, right? So for example, if I trying to test a e-commerce system, right? The guidelines and the standards that I use it to test that system is going to be different than if I'm testing a system that launches a rocket, right? The predictability and the accuracy that needs in one segment, it's going to be completely different than the other segment. That's why what you're going to see it in the software development world, as you start writing the test plan, you kind of identify just the processes that you're going to follow. You're going to essentially identify the techniques that you're going to follow. But there is no set standard that, hey, if you're doing software testing, you should do this, this, and this only. And as long as you do those three things, your software will be tested validly. You cannot predict that. And that's why it's more templates and guidelines. So you identify, hey, what templates you're going to use it, what guidelines you're going to follow it in order to do this testing for this particular application. Any questions so far? Okay. Now, in addition to identifying what you're going to test it, what are the scenarios you're going to test it? Most of the test plan will also talk about something known as environments. Okay. So in a software development world, there are various environments that you interact with it. And here are the most three common categories of the environment. Okay. Let's start with the left, right? So this environment. Okay. So think about it small, or what is the example? Have you watched the kids doing a puzzle? Right? Do they like it's kind of every piece that they put in, it's always perfect first time? They're not, right? So they work on it something that, hey, I'm going to try to perform this part of the puzzle, see if it works. If it doesn't work, I'm going to break it down all the pieces. And I'm going to go ahead and re-put it then. Till I become satisfied that, yes, this part of the picture that it's talking about puzzle, it's coming out perfect. Then I'm going to work on the next part of the picture, the next part of the picture, right? That's the mode that the kids will work on the puzzle. Same way in the software development. So software developer, they get the requirement, they get the program specification, and they said, okay, I'm going to try to build it. They build it, and they run the unit test. It says, okay, am I satisfied with this piece? And they said, no, it's getting an error. Well, let me scratch that thing and rewrite the piece, or let me try to fix that piece. Right? So they're constantly changing things. And when they're constantly changing things, it's kind of like it's a kid's making a puzzle, or a kid's on a beach trying to, like, it's working on a sandbox trying to make something. If they don't like it, they're going to destroy it and they're going to rebuild it. Right? So what that means is it's highly unstable environment. It's constantly changing. Right? If I'm a tester, and if I want to validate that did the kid build the castle on the beach properly or not, right? And they're in the process of building it, I can't say it whether it built it right or not, right? Because they could like look at then, hey, I try to build it, and then as soon as I try to put something on it, it collapses, right? So for me to validate that it is being built properly, it's going to be very skeptical, right? Because I can't tell it till actually the person is done with the work. Then I can go and inspect and says, is it working the way it is or not? Right? Same thing, when the developers are working it, a lot of times you will hear a word like sandbox environment or the development environment. It is a highly unstable from the point of view, from a testing point of view, because they're constantly building it, they're constantly doing it. Now, in the modern day world, right, where you have multiple developers coming and collaborating it, I might be building one piece, Herschel might be building another piece, right? And I'll be constantly tearing it up and rebuilding my piece, Herschel will be doing it. And we both are also trying to say, hey, I'm trying to provide you this interface. Let me give you that. And then bring it down, he's working on it, he brings down his piece, right? So the connection is not going to be consistent either, right? So even though it's a development environment, it may be more stable than a sandbox, it's still not suitable for me to perform any kind of testing, because I can't guarantee everything is going to work exactly the same way from one time I run the test to next time I run the test. Because my underlying system is changing. Remember one of the characteristics we talked about needs to be repeatable and predictable. I can't predict it. Well, not because I wrote a bad test. I can't predict it because the underlying system on which I'm testing is constantly changing. Okay, so that's the development environment. But at some point, the developer is going to finish writing it. They're going to say, I'm happy, I ran my unit test, everything is working as expected. And they said, this piece is now ready for you to test it. Okay. So what they're most likely they're going to do is going to take that piece from this environment, and they're going to give you in the second environment, which is this environment. Okay. And if you think about it, this is the gate that they do it. They said, hey, you know what? I'm going to release it and I'm going to give it to you. But once I give it to you, it's all yours. I'm not messing with that. Okay. So as a tester, then you come and you go ahead and say, okay, now that the system is stable, I can run my test cases and I can run it repeatedly and see it if it's predictable every time or not. If it's not giving me the same answer every time, but I know the system is now stable, then the only conclusion is my test cases are not proper. I need to fix my test cases. But also I have the functionality that they say that it's working, that I'm going to go ahead and test it multiple times and make sure that it works. Now, depending on the level of testing I'm doing, remember the V model, right? I could be doing it only a system test, but I could be doing an integration, right? Because each individual component, I still need to bring it together and test it to make sure it works. And then once each of the component is working, I'm bringing that together as a system. So I could be doing either one of those testing, depending on what kind of software I have it. Then I could also be doing an end-to-end testing. So if you think about it, most of the times, the system that you build it doesn't exist in isolation, right? They exist in the concert with some other things. So let's take an example that we talk about the Amazon, right? So we talked about, hey, I have to worry about inventory, making sure that all of my inventory information is up to date so that when somebody's ordering the book, I can tell it whether I can ship it or not, or is it in the back order or not. Right? So typically you're going to have a different inventory system because the users of those inventory systems are most likely the people who are providing that book to Amazon as a supplier, right? Once that big bulk comes, the Amazon employee behind the scene is going to update the inventory, right? But also that inventory system interacts through my e-commerce system, which is my ordering system, because they are the one who are kind of reducing the inventory. Same time, somebody returns the item back, I need to put back into inventory, right? So if I'm building an inventory management system, that inventory management system doesn't stand in isolation. It has to be working in conjunction with the other systems to perform my overall business. So what it means is I may have an inventory system working fine, but I need to make sure that now it's working fine with the other systems in the ecosystem. So when I do those kind of testing, that makes sure it works fine with all the external systems. A lot of times it's known as an end-to-end. So I'm walking the entire business scenario end-to-end function, not just this particular system only. Then you also have a load and performance testing. We talked about, hey, what if there are like 1,000 users working on the system at the same time versus 10,000 users? Does it still perform and behave the same way, or it degrades in terms of performance? And then we also talked about user acceptance testing, right? After everything is working, I'm going to give it to user and says, now does it meet your requirements? Can you validate it and accept it? When you accept it, that's when I'm going to release it. So it could be one of the 5 different types of environments. Now, depending on how big the company is or the scale of the project is, you may have a dedicated environment for each one of them. Or you may have only one environment and you slice it based on the time. You're going to perform, first week, you're going to perform this to activity. Once it's done, then you're going to perform this to activity and so on. So you may still have one environment, time slice to perform the different functions of the testing. Or you may have 5 dedicated environments to do each one of them. Or you may have combination that, hey, you know what, my end-to-end load performance is one environment. This too is a one environment and so on. Okay. But as a quality assurance person, this is the environment mainly that you're going to play around with it or do your work most of the times. Yes?
So how do you know your test needs a fixation versus if it has to go back to the developer or not?
So when I'm performing all this work here, performing test, if my test case starts failing it, that means I'm finding the bugs, right? I communicate back with the developers. Developers take that bug and work in their environment because they have to fix it, right? While fixing it, they're going to change the system. Once they change the system, they're going to continue testing and says, yep, it's working now. They're going to give you a new release. They're going to give you a new build and says, okay, you know what? You no longer need to test that old version. Here's the new version. Test this version. But that frequency is not every hour or so, right? That frequency is probably once a night or once a week, depending on what agreement you have as a tester with the development team. That frequency is one they give you. And in between that frequency, you have a stable environment. Because think about it, every time they finish the work, if they keep pushing it, your environment is not stable again. So that's why those agreements are usually put in place. And that's where in your test plan, you just say how often that environment will be refreshed. So that there is a clarity from both from a developer point of view, as well as from a quality assurance person that, hey, what should I expect it? Okay. Does that answer your question? Okay. Now, once I've finished all the testing and everything is working as expected, and the user says, yes, I tested it and I accept it, go ahead and make this as the real live environment where customers can use it. So that process, they usually, when they accept it, they migrate into production. A lot of time they say it's a production release. Okay. So at this time, you have a live customers performing those things. Now, as a tester, right, I like to say that, hey, usually you draw a boundary here and don't try to go into this environment to test it. Okay. Because think of this, right? Hey, I'm trying to see it if I can delete a custom as a feature, right? I'm testing that. Accidentally, I go into production environment and I delete it. Real customers. And this does happen. I won't name the names, but for 20 years, I worked in a telecom firm. Okay. We have massive, what we call it is the pipes or fiber that runs across the country. And that's where all of the customers are actually using the traffic. And we have a similar test environment because we have to test it, make sure as the new technology comes in, right? Think about like 4G, 5G, as all those new networks comes in, this has to be a test environment. There has to be some play field for us to play with it. So we were like, it's testing it out, some script to say, hey, when a customer leaves, all those circuits is no longer being used, how we can recycle it and make sure everything works fine. So we were running some test it, and then we were doing in some test switches. And somebody said, okay, let's just see it accidentally. Let's just read the data from production and then copy it so that we can actually simulate what's going to be out there when we go to perform those, what we call it is a circuit pruning out in the real world. Great. Somebody thought that they were pulling the data. They changed the configuration to point to production. And they ran the test to purge the circuits. We're in the middle of a busy day for a lot of our customer, and the purging went and cleared out all the circuits. So there all of a sudden, there's no internet for any of those customers. Think about it. In the middle of day, busy customers, and a lot of them were media customers, that they can't get any of the information or news out anywhere. Took 2 hours to restore back what was wiped out. Right? So it's not just the impact when you do the testing, that, hey, I tested it. You actually brought down the customers, you impacted the revenue of the people, and you essentially created a reputation harm. People said, hey, you know what? Really, I want to be there? Because they test the things into production and they wipe me out. Right? So that's why I try to draw this boundary that whenever possible, you don't touch the production environment as a tester. However, there may be a scenario where as part of risk contingency, you may have to test into production environment, but make sure whatever you do test in production environment is non-destructive. That means it's not changing any data. It's okay for you to read the data from production, don't change it. Okay. But essentially, that's the 3 sets of environment, and that's where you focus on it. So in your test plan, you identify this is what you do it. Now, for very small firms, it's very difficult for them to create 2 separate environments because of the financial, right? So they may just do a time slice and say, hey, you know what? For production, you will use same machines as a test, but you can do test only during this time only. So now that becomes a factor in your planning for the test plan. Okay. Any questions on this environment?
So I have a question. So if as a tester, I'm performing any test, like sales system test or integration test, whatever it is, so and I'm not able to find any bug. So is there anyone will inspect my test cases or test scenarios?
So there are a couple of things happens, and it all depends on how big the company is. Okay, if you're working in a company where you're a sole tester, probably sometimes you will partner with the developer. But typically, as you're writing all those test cases, you tend to go through a peer review type of process. So if there are multiple testers, you write it, and then you can quickly validate with somebody. In an agile world, it's a lot more easier because you're working with the developer at the same time. They're writing the code, you're writing the test, and you can converse with them and validate it. A lot of times, when you test it, it's still your responsibility and accountability to make sure you test it the right way and put an account on that, right? So a lot of times project managers will just look at the log and says, did all the tests pass or not? But they will trust you because you have the skill to write the test cases and do that and do it. In some critical systems, like 911 systems or any of the health care systems, which impacts directly the patients, like is whether I'm measuring the heart rates and all those things and the systems that you write the test to that. those things are always typically you have a pair. But somebody writes it, there's already somebody who's reviewing and validating it before going in. So it's not kind of, the whole goal is not that they don't trust you. The whole goal is that if you miss something, somebody else is already catching it and addressed it. Because the impact of not doing that job properly is significant. It costs people's life. Okay. But again, it all depends on the scope and the type of projects and the budgets you have.
So isn't the agile world a better world to stay in, where communication is often and things can get fixed step by step versus at the very end?
That's what the whole mindset is. That's why a lot of companies are shifting towards agile, right? But not necessarily that agile world is perfect world either. If you are not good enough in terms of what we call it as emerging design and emerging architecture mindset, then if you build something and now you're like it's kind of adding something else and you're rewriting everything, that creates a problem, right? So it's, as I say, right, everything comes with its own benefit and there's always the downside of it, and you just need to be mindful in making decisions. One of the things that you are going to encounter as you go into the software world is there is no right or wrong answer for everything, right? It depends on the situation, what is most effective answer, and that's where you're going to focus on. Okay. Now, we talked about the environment. We talked about the scripts that you write. There's another aspect that you need to identify in the test plans, and it's known as the data, right? So as I'm testing things, I need to make sure I identify what data that I'm using it in order to test with. Okay. So for example, if I'm a lender and I'm focusing on approving or rejecting a credit application, I need to focus on what is the credit application, what specific data, and is it in the right state for me to perform an action on it, right? How do I set it up then? That entire aspect is known as the test data and test data setup. Now, it's much more easier if you have a system already out in production that you can pull the data copy from production and then work on that. But if you're building a completely brand new system which has no data at all in production, then you have to come up with the data, right? A lot of times it says, what are the mock-up data that you've created to build your test cases and test scenarios to simulate what will happen into production more. So as part of test plan, you have to be very clear in terms of who is creating the test data. Is it going to be provided by the users, or is it something that you need to create it as a tester? Because if you have to create it, there's going to be an extra effort, right? Because you have to come up, you have to populate the data, and you have to take some time to build those things. Versus if the users are giving it, then you have it. All you have to worry about is update the environment with that data. Okay. And all of your test data should be such that it supports both positive and the negative scenarios. The example that I talked about, right? In Amazon, if I'm performing a checkout, I need to make sure my data contains valid credit card, a valid account with a credit on the Amazon, valid PayPal account where somebody can do that, as well as invalid PayPal account, right? Because I don't want it to go through it. If somebody gives you, I want to make sure I'm able to prevent fraudulent accounts. Then it also talks about the test execution, how long you will be performing execution. And sometimes those execution would be an engine, right? So you could be doing an automated test, then what are the scripts you're writing it, and then what platform it goes with. Versus if you're doing a manual, it's still manual execution, still on the script, but you have to say that this our test is going to perform manual versus here are the things that I'm going to automate it, and here are the platforms which you're going to use for automation. Okay. How do you define manual versus automated testing? So when you're writing things in test plan and you're identifying something as a manual versus automated, well, what does that mean to you? So manual is, if you think about it, any test that requires a human intervention is by default, that's a manual test. Okay. So when we talk about user acceptance testing, where actual end user will be performing the test, it's all manual testing. Versus automated testing is something that it happens automatically based on certain events or triggers, and no human is interacting it during that testing time. So a lot of developers nowadays, what they do it is when they're building the software, a new version, they essentially write it down to such a way that as soon as the software is kind of built, it automatically kicks off all those tests. It runs it, all those unit tests to make sure everything passes it before saying that, hey, it's up and running in the new environment. Okay, so you're going to see a lot of times that code-driven or user interface API-based, those testing is going to be automated. Now, again, it depends on the scope of your system and how the development is done. Some of the things that I talked about, test-driven development, the mindset is that, hey, I'm going to build a test that could be run automatically based on time events or trigger on certain things happening. And nobody ever needs to touch it. Okay. And this is where you're going to start seeing a lot more that unit testing, which developer does it, which requires an intimate knowledge of the internal systems. Those things are typically done automated way. The things that requires a human validation, like user acceptance testing, are typically done manually. Right? So a lot of times, functional testing is done manually the first time you're building the system, and at some point they will start automating functional testing. Okay. Let's go a couple of more concepts and then we'll just take a break. Okay. So the next thing we talked about is the metrics. Right. So one of the metrics that typically it's talked about is the test velocity. What that means is within a given period of time, performing certain tasks, at what rate you're performing that task is known as a velocity. So you can just say, hey, in 24 hours, I'm able to run this many tests, or I can write it this many test cases. Because remember, in the first earlier part of the development cycle, you're just writing it. You're not executing anything. So you may still provide it, hey, I have to write 500 test cases. I'm done writing 30 test cases. And I'm able to write it like it's 5 test cases per day. So that gives you a velocity. That gives you how long as you still have before you're done with writing it. So it is also gets you an understanding of projection as when you're going to meet your goal that you've set it up. Then it talks about the various test reports. Okay. So some of the test report talks about what is the progress, right? So it gives you an indication of the progress you are making it as you go through it. In case of Agile, it's fairly easy, right? Because you have just 2 weeks. All you're doing is, I wrote this functionality as a developer. Is the test ready to test that functionality? Because I'm going to deploy that every 2 weeks into production, right? So I need to make sure that everything that you wrote it is tested thoroughly before we can deploy. That's fairly easy to measure that. If you're in a waterfall world, that's where things gets it, is that, hey, I need to make sure I'm providing the right progress for the testing. Because somebody else is writing the code while I'm writing the test scenarios and test cases. So when they're ready with the code, if I'm not ready with all the test cases, then there is additional delay. Okay, so it talks about, some of the test report talks about the progress of testing. How many test cases you've done it, how many are left, what is the rate or velocity at which you're testing it. Some of the other thing we'll talk about is the quality of the software being produced. Remember, I was talking about process metrics versus product metrics. So anything you produce around the product metrics is essentially giving you a quality of the software being produced. How many bugs I was able to find it? How many units or components I was able to successfully test it, right? The other thing could be is that, hey, this was working first, but when you fix this error, none of this thing works anymore now. That also gives you an indication of the quality of the product. That, hey, whenever they fix something, something else breaks it. Right? And the last part is, it's making sure, based on all those trajectory, am I going to meet on the timeline that I kind of originally projected? Now, here are some of the examples, right? We talked about, hey, if the function, there are 5 functions into the system, at which point what function was working fine. So it gives you an idea, hey, what portion or capabilities or features of the systems are ready to go. So if I have to do a risk mitigation and say, hey, you know what? We are still going to release it. Tell me what is working that I can give it to the customers. Gives you an idea of those things. It also gives you an understanding of how many defects you found versus how many you fixed. Gives you average age of defects. In other words, if I find an error, how long it takes it before I kind of say that that error is fixed now, right? So it gives you duration, and then it gives you how long outstanding defects are and what is the age of that. Is it 10 days, 15 days, a month type of thing? Also gives you a defect distribution. Well, if I have 5 modules or functional modules in the system, how the information, how the defects are scattered all over across them. So it gives you an understanding, is it one particular segment is troublesome of the system versus the other one. You can also, like, it's kind of just say, hey, if I have X number of test cases to test it, I can start saying, hey, this many are tested, working fine. This many are tested, but has a defect that needs to be still open and tested again. And this many I haven't touched it, that still needs to be completely tested. Okay. We talked about all of these things. Then as you write the test cases, and then you start identifying the defects, there are severity levels and the priority levels associated with them. Those are 2 different things. Severity level means how impactful this is. Okay. So things could be cosmetic to all the way to critical. Okay. Criticals are the things that it says, hey, if this are not fixed, the systems are crippled. So for example, if I'm like it's providing a credit application and the system has a bug that doesn't allow me to capture the social security number. Now, you know that, hey, in order for any lender to consider anybody for a loan, they definitely need your social security number, because that's what they use it to pull your history and the background and all the information about you. Well, if I can't get the social security number, I can't pull any of those reports, so I can't determine whether this is a valid, quote unquote, a reliable customer whom I can give the loan or not. That means I can't perform my functions. And if I can't essentially approve or reject it, there's no point for dealer to keep creating a credit application that nobody can work on it, right? So that is used as a crippling issue for my platform. So that is considered as a critical. I better fix it. Versus something is that, hey, you know what? On this particular screen, my company's logo is not getting displayed properly. It should be this color instead of this color. It's a cosmetic. By not having that fix an issue, probably is not going to have a lot of significant financial impact. Can I go into production with that? Sure, I can, right? Because everything else is working just as expected, except that particular thing. And I can still work it. So those are the 2 extremes. And then in between, depending on the criticality, you will have high, medium, and low, right? Same way the priority levels. Now, the priority is a little bit different than the criticality from the point of view. As a user, what function I needed to be working first. To me, what feature system should have is the highest priority versus what is at the lowest, right? So let's take an example, right? If I say that if I'm building a house, right? And if they say, hey, what should be working, right? My first reaction would be, is it should be functional. So if you build a plumbing system, right? Make sure all the water inlets and water outlets are working properly, because those are the highest priority. Whenever I turn off the faucet, make sure the water is coming in and it's draining it properly so that things is not collecting it up. That is going to be my highest priority. Now, the low priority, they said, hey, does it needs to have a fixture that I selected it, which has this capability that it can not only just turn on, but I can just go and say this has to be shower type of thing, this versus a continuous flow. If that's not available and they say, hey, do you want it? Can I put a temporary fixture that still allows you to do this thing? And I can put all the different fancy feature later on. Will that work for you, right? To me, those things will be lower priority. Because if the water is not flowing through it, putting a fancy fixture is not going to solve my problem, right? So if the constructor guy comes in and says, hey, you have two choices, what do you want to do? I'm going to say, the water has to work is my first priority. So I'll define those features that to be implemented and tested as a high priority. And the other ones that, okay, if it's not that I can live with it, will be most likely low. Okay, so when you define all those test cases, you also work with business and you say, hey, which one are high priority? And typically you take the guidance as which are the requirements which are high priority, they are the high priority test cases. If the requirement is low priority, they're not going to be high priority test cases. Then you talk about test metrics. Okay, we talked about the product metrics and process metrics, and here are some of the examples. Okay, how many paths I tested is a process. How many acceptance criteria tested is a product metrics, right? Because hey, there are 500 acceptance criteria, I'm done with 300. Gives me a view of how much product is tested. Cost to locate defect is another process metrics, right? How much time I have to spend it in order to find a defect. Am I writing effective test cases to find the things right way? Okay. And then you talk about the test tools. Remember, we talked about the resources. I need to identify what all tools I needed in order to perform my function for testing the software. So here are some examples, and we'll look at some of those tools as we go through the testing. Okay. So let's take, what's time right now? It's 10:38. Let's take about a 7-minute break and then continue back at 10:45. So feel free to stretch your legs. Okay. Online, we will come back here at 10:45, so give about like 7-minute break.
Thank you. something you do. Maybe it's like 10 feet. Okay. Oh, okay.
I'll just use PDF.
Yeah, and then that's fine. Yeah. That's it. What is it? Yeah, I think we just should put yes down. Presentation, we take it down a little.
Projecting out. It's not projector. It's this one is kind of condition and reflection is coming out pretty bright.
Yeah.
That's what it is.
Yeah, it's still the same.
It's still that. It's the brightness on this one.
Yep.
Does this make a difference for sure? Yeah, for sure. You could see it better with this thing.
Okay.
Did we go to 1 or did we go to 12?
Huh?
Did we go to 1 or?
We go typically till 1.
Oh,
Yeah, we'll probably stop somewhere between 12:30 and 1.
Yeah.
Sitting there and it's like really right on me. Instead of what? I don't know what.
There's no glass.
Yeah, but
There's no glass. No glasses.
no, it's open. They
Oh,
or
yeah.
yeah, I trapped it open. Yeah.
Oh my God.
then go to the bottom.
Okay. If you guys want to drink water or something, we do have it. It's just that we ask you to typically bring the water bottle from home, so that we avoid the contacts and all those things with the water thing as well. So feel free to grab it, okay? If you don't have water bottle and if you want to have anything.
That's what I'm gonna yeah, that's for me.
I got somebody coming in.
Okay.
So I'm gonna sit there for a few minutes.
Yeah.
I'll be back. Good values.
Right. Right, guys ready? All right. So let's start. So there are a couple of things I want you to start thinking about it. As you write the test plan, one of the most important thing is for you to give an estimate, right? So typically the scenario will happen is they will give you, here is a requirements document. Okay. Along with the test plan, one of the important things I want to do is tell me how long it's going to take you to test it. Because I need that data to put together the cost of what it will take it for us to build the software and give it to the customer so that they know what it's, whether it's an internal or external, doesn't matter, right? Because even for the internal customer, you need to give how long it's going to take it and how many people and how many resources you need in order to test this thing, feature capability. So think of it, if it's all of you read the R-Flown system, right? So if I come and tell you this, okay, give me an estimate how long it's going to take you to test it. Okay. So how are you going to come up with that? So let's talk through it, right? So let's go around the room and based on your understanding, right, whether it's right or wrong, right, we can figure it out later. Let's go through it and in your opinion, how long it will take you to test it. So you tell me, if I give you a R-Flown system and say, hey, Nisha, go ahead and test this system, and you tell me how long it will take you to test it. So what would your estimate would be, or guesstimate? Because this time we are guessing it.
I have to say time period.
Yeah, just tell me whether it's going to take you 1 day, 10 days, 500 days. Tell me how long it'll take you to test it.
I would say 1 week.
1 week?
Yeah, one.
Okay, so I'm going to put, I don't know why it's not writing it. Oh. So you're saying it's 5 days? 1 minute. So everybody can see it. Okay, so you said it's 5 days. Okay. What about you, King? How long do you think it'll take it? You have to speak it loud. I can't hear it.
1 week.
1 week. So you are with Nisha. It takes about 5 days. What about you, Nara?
A week, I guess.
Okay, so you're also a week. What about you?
4 weeks.
4 weeks. So I'm going to put 20 days. I'm just assuming 5 days a week. Okay. So the way I'm calculating it's 5 working days in a week. So when you say it's a week, it's 5 days. What about you, Niti? 10 days? So I'm going to say it's 10 days. Okay. What about you, Megha?
6 weeks.
6 weeks. So I would put 30 days. What do you think?
I'll say 2 weeks.
2 weeks. So here's what I'm going to do. I'm a programmer, right? So I'll just identify how many people. Say on that. Okay. What about online?
I'll say 6 weeks as well.
How many days?
6 weeks, 30 days.
30 days. Okay. What about you? Valerie?
I'll go 2 weeks, 10 days.
2 days. Okay.
Mhm.
All right. So here's my question. Just like what we did it for the business analysis for the business problem, is all of you had the same requirements document. Okay. You have different things that you came up as an estimate, rough estimate, right? So obviously there is some logic why you think it will take a week, right? Even though it may not be formal logic, some think it, right? So tell me, what are the factors that you consider when you say that it's going to take you that much time?
I think of that, I said 4 weeks just because like the first week's for analysis, second week to execute.
So you say it's analysis.
Yeah.
So analysis, I can't type today. Analysis, then you said execute,
Executing.
okay?
and
Okay,
then checking the bugs, and then the fourth week to review stuff.
okay, and fourth week is to review. Okay, so in your mind, the review is going to take significant same amount of time as the bug and execution. Okay. Anybody consider any other factors? Online, do you guys think about any other factors?
Would planning be one of it too?
So do you consider analysis and planning same?
Yeah.
Yes.
Okay, so I'm going to put that as a planning factors. Okay. So here are the type of things you think about it, right? Here's my question to all of you. How many test cases do you think you need to execute or plan for it? You have a system, right? So how many test cases do you think that you'll need?
Like what kind of test cases you do?
So you're testing, right? Different functionality and features, right? So for every features or functionality, you're going to write the test case. How many test cases do you think you have factored in to come to your analysis of 20 days?
So, is it not depending on the application testing or any?
But you have the requirements document, right? So you exactly know the scope of what you're going to test. Because you all like it's put a number out there, right? Obviously, there is some mental calculation of what you did it in order to come that number. What mental calculation you did? That's what I'm asking.
Outside 80,
How many?
80.
80. So your estimate is 80 test cases, right? Anybody higher or lower? How many? 70. Okay, so other than that. Okay. So how did you come up with that number 80?
I think of like doing 4 test cases a day makes it work slightly easier than doing 80 at one day.
But how did you came up with this number 80, that I have 80 test cases to test?
I think of I just guessed like it's supposed to be between like 80 to 100, and I said 80.
So it is just kind of
Yeah.
that number. That's what most of the developers do. And testers do it. Okay. But more, huh? What his rationale was, I don't have any data. I'm just going to pull a number from the air and going to throw a number out and going to see if it sticks or not. right? That's kind of like, it's a lot of times like you play a game, right? And just they say, how many birds on that tree? You just throw a number, right? And see if it sticks or not. That's what he did, which is okay, right? I'm just saying a lot of people do that. So the way I want to think about it is, if I tell you, test, you're on hook to test it. I gave you a requirements document. You came up with 20 days. Okay. I want you to finish your work in 20 days. And at the end of 20 days, if you're going to come back and says, hey, Dalip, I need another 10 days. And we said, you get those 10 days, but I'm not paying you for it. And as a penalty for not doing the work on time, I'm going to charge you extra money for every day that you're delayed to it. Will you still keep your estimate the same? Will you still use that technology to come to estimate?
No.
No? Why not? We were confident that 20 days, 80 test cases, you came up with your logic of 4 test cases a day. Why didn't you do that?
I'm pretty confident, but the thing is that I still think the numbers from the year, so like the 90% of the chances it might not even fit.
Ah, so you're just saying, Ismail, that you gave me an estimate that 90% of the time you think it's not going to work. I have a company to run. I have a reputation to run. Am I going to depend on you?
Not really.
When you're saying it's 90% of the time, it's not going to work. Okay, how many of you are willing to work in that mode? Right? Now, take it and impact on that. If this is a critical system and people are relying on it, and you just say, my estimate is only 10% good, right? It's going to be like it's saying, hey, Fitz, you're going to graduate in 4 years. And he says, Dalip, I'm only 10% sure I'll graduate in 4 years. And your parents are paying the fees. How happy they will be.
No.
Right? Think about it. There are implications. So what you want to get it is when you're doing it, a software quality work, is you need to base all of your work on some sort of model, even if it's guesstimate. You want to understand what model you're using. Okay. So one of the ways you can do it, okay, and it's just fairly common, is an experience, right? The more the experience you have it, you know, hey, how long it's taking this kind of system to test it. But if you don't have that experience, then you look into something, a more logical structure way. Okay. And I'm showing you an example, right? And we can talk and debate it whether what it comes in, right? But the way you can think about it is, hey, let me take the system document, requirements document, let me break it down. Okay. What is the most common thing I'm going to test it as functionally? I'm going to essentially pretend one type of user or other type of users and I'm going to do the testing, right? So let me start there and say, okay, how many different users I'm testing? For each user, what are the high-level scenarios I'm testing? Because I could easily come up with that, right? By looking at the document. And then I can say, okay, are those scenarios has specific variants that I need to worry about? Just put it at a high level. I know I don't have test cases written, but now I can go some more logical. And then I said, hey, if I want to test the login, how many test cases I think I need? If I'm trying to do it something as a search function, because site administrator need to search the dealers, need to search probably a credit application, or maybe need to search a lender or something. Well, how many test cases I need? So I can come up with a guesstimate of how many total cases that I'm thinking about it, instead of just coming 70 to 80 number, right? With the experience, you will probably come with a more than, but it's still, there is a risk involved in that estimate. So I would say, think about the scenarios, put it that, come up with the test cases, right? And then if you want to get a little bit more advanced in terms of your estimate, you can just say, hey, is this scenario complex or simple or medium? Obviously, like the login scenarios be a lot more simpler than testing it whether I submitted credit application successfully or not, because there are so many data and so many fields available, right? So you can put an estimate and you say, hey, you know what? In order to do this, I need X amount of simple test cases Y amount of medium and Z amount of complex. And based on my experience, complex test cases takes this much time. So I'm going to multiply by those things. And I come up with an estimate based on that. This is how long it's going to come, which is now much more highly reliable than the number I put in, because, hey, you know what? I had some scope understanding before I did it. So the way you do it is you come up with that, right? You come up with all the different test cases. Then you essentially look into it. Okay, writing test cases is not the only thing I do. Right? As a quality assurance person, there are a lot of other things I do. So let's just put it in what I'm going to do. Let's see if I can do this. Okay. So I can do some sort of requirements analysis. That's I'm going to spend the time, right? Nothing comes free unless you want to work for a free, right? You're going in a profession where you're expecting it for every work that you do it, that its time is accounted for, right? So you're going to say, hey, I'm going to do a requirement analysis. And for that, I'm going to say it's going to take me 3 days because I have to read through the entire requirement document. I have to manually do that 3C and a T, make sure I understand what the user wants it. Based on that, I need to come up with a breakdown of the different scenarios and how many users and so on. Then I need to build a test plan. I need to set up a test environment, right? Because those tasks are independent of how many test cases I have. I need to still do those things. Then I'm just saying, hey, I'm going to take 32 hours to write the test cases because I've identified this many test cases. If I put heads down and just keep writing it, it's going to take me this much time. Then I'm going to go ahead and factor in certain amount of overhead, right? So the way that you typically work it is based on industry data. It said, hey, you know what? On an average, you spend this much extra hours in terms of interacting with the people, asking questions, waiting for the questions, answers, and all this kind of thing. So you factor it, and then it says, in order for me to just the design test cases, it's going to take me this much time. Then you go say, okay, now that I have done the design, how long it's going to take me to run those test cases? And remember, I can't just run it only once. I have to run it once, assume that some of them is going to have a defect. So I have to run those things again. But I may also have to run the ones that passed earlier successfully also to make sure when they fix the bug, they didn't break anything else. Right? So I may have to do at least two sets of test execution. First one is with first time, tell them here are all the errors, they fix it, and then I redo it. And I'm hoping in ideal world, they will fix everything that what I told them to do it. So I'm going to do two different test cycles. I'm going to have to spend some time interacting with the users or developer and says, hey, this is how I find the defect. This is what I'm seeing as an issue. So I'm going to put all those total. So I'm going to have an execution of sets of hours. Then I'm also going to go ahead and once I'm done with it, I'm going to sit down with the users while they're testing it. They said, oh, this is not working or this is not working type of thing. So I'm going to provide some sort of support. And then I'm going to put some contingency factor, just like it's, hey, interaction, overhead, and so on. And then once it's all done, they're going to expect, once you release it, there might still be some issue and say, hey, why this is not working or that not working? I may have to retest some of the things. So I kind of put all those things and then put the total effort. And then I take it that and then convert into hours, right? So initial estimate that we came up while we were like building this system was it's going to take a 67 man days to test it, right? Which is roughly when you take it 5 days a week estimate, right? It's about 13.5 weeks to 14 weeks. Okay, but this is how you come. So now you know that estimate that you gave it was based on certain valid logic. Okay. Now, obviously, like it's depending on the amount of the test cases. If it's 80 versus 500, guess what? 500 is going to take way more time than 80. So you need to factor in appropriately the times and so on. But that's how you come up with an initial estimate. And then that's where you give the ballpark. Hey, it's going to take us about 14 weeks to test it. Now that 14 weeks, they may say, hey, It may be in a waterfall way. Or it may say, okay, I'm gonna have the development, it's gonna have a 7 sprints, and each sprint it's gonna be 2 weeks. And it says, okay, then I need to provide support for that much time. But during each sprint, I'm expecting this much time for testing. That's how you come up with an estimate. Okay? Because believe it or not, first thing, as soon as you go to the work, first thing you're gonna do is kind of drop a system requirements document and says, tell me how long it's gonna take you to test. Right? So you need to have some mindset of how I'm gonna come up with that estimate. Okay. Any questions on this one? Okay. So your homework assignment, before we go in, and then we'll recap it at the end, is the third document in that series of documents is the test plan document. Read that, understand that. So it'll give you an understanding of what it is. As I mentioned, most likely, no matter where you go, there will be some test plan template already available. And typically, you update about 20 to 30% of that document to customize from a system to system. Almost other information are more or less kind of same from a project to project. Okay, so that's something that I would like you to read it between now and next Thursday. And make sure if you have any questions, we can talk about it. Okay. Good? Okay. So let's talk about the some of the terms that you're going to interact with the testing. And this is the last big topic that we're going to go through it in terms of theory. Once this is done, pretty much all the foundation is set. So starting tomorrow, we'll start writing actual test cases. So what you're going to see it is the amount of time that I speak, it is going to drop significantly in the amount of time we will do as actual work, like what you will do it in a normal work day as a quality assurance person. That's what we will start getting into. Okay. So when you talk about testing, this is now you're coming at the execution part. Okay, so when you look into STLC cycle, the planning and execution. So this is start focusing on what different types of planning you need to do at testing and the terms that you use it, and when you execute what type of testing. Okay. So let's talk through it, each one of the term, and then understand when and what time in the life cycle of this system development you do that. Okay. So at a high level, when you look into different views, one of the views people say it's, hey, what type of testing you're doing? Is it a static or a dynamic? Okay. So let's understand what each term means. Static testing is typically a testing that you do it without running any sort of programs. You don't have a system to do it, you don't have anything to run. And when you perform a testing at that point, it's known as static testing. Some of the example is when you're doing a document review to identify, hey, what is missing? That's a static testing. When I ask all of you to do 3C and a T testing, you don't have a system, right? You just essentially read it and say, hey, this doesn't meet this thing because those two are inconsistent. Well, we need to fix that. So that's a static testing. So typically, whenever you're doing your reviews, they are a type of static testing. Any of the inspections. So when you start writing the code, one of you mentioned, right, Niti, that, hey, if I write a test cases and I run it, is anybody looking at it or it's just me doing it? So when you say it is, hey, I'm running it, but I wrote these things, I'm going to sit down with another tester and review it to see if I missed anything. And once I run it, I'm going to show the log to that person to say, did I interpret things correctly? That's nothing but somebody is inspecting your work or doing a peer review. That's type of static testing. Because that other person is not running anything. They're just sitting down and reviewing if what you did and does it make sense or not. Okay. Another type of testing that comes in is a compiler. So this is a developer type. Okay. So the way the developer write the code is essentially they don't write into the machine level instructions. If you look into it, they will write something known as Java or C++ or a C# language where humans can interpret correctly. Okay. What they do is they take that code and they run something known as a compiler. And that compiler is designed to say, did you use proper syntax? Right? So if somebody is writing an essay in English, right, and somebody else is writing into same essay instead of writing on a piece of paper, they're writing in a Word document. As they write it, right, Word flags it, hey, this is misspelled or this is that. And nothing but that Word is checking your work to make sure you're following the proper syntax and proper grammatical language. Same thing when you're writing a software programs. There are things which known as compilers. They essentially take that program that you wrote it and you run through the compiler and the compiler tells you, did you follow the same syntax, proper syntax? Do you have the proper quote unquote rules of the language that you followed or not? Okay. So, and then if you did, that compiler then gives you a code that can be then executed by system. It's not, I would say it's that human readable. It's more a machine level instruction. Remember we talked about the firmware when I talked about the 3 layers of computer application and programmers. So that firmware is essentially a machine readable instruction that will code. Okay. And that's what the compilers are. It provides that machine level instruction so that it can be executed on the operating system or on the hardware. So that thing is nothing but a static testing because it's testing developers' work and did you follow all the rules right way or not? It doesn't test it, right? So if I'm writing an essay, Microsoft doesn't test it. Did I write the right essay or not? Right? So compiler doesn't test it. Did you wrote the proper logic to add the 2 terms or 2 numbers or not? It just says, did you follow all the rules or not? That's how it's compiler does it. So typically you're going to see some type of static testing whenever people are doing code review or requirements review or doing any type of peer reviews. Now it's an important. The primary purpose of this thing is to verify. So there are 2 terms you're going to think about it. One is verification and one is validation. Verification is the intent met what you're looking for? Okay. And validation means I'm proving it that you met the intent. Okay. So when I'm running dynamic testing, that's when I'm validating it. Okay. A verification is always preferred over validation. Here's the reason why. When you're validating, the error has already happened into the system. All you're just doing is validating that the error is present, or you're validating that there is no error is present. You want to do verification because verification is before you build anything, you're preventing an error in an earlier stage. That is it supposed to do what it's expected to do? Anytime you do a functional or non-functional testing with the software, they all are dynamic testing. Okay. So that's one view. The second type of view you could take it is whether it's a black box testing or a white box testing. Okay. So when I gave you, it says, hey, go ahead and like it's tested whether the checkout functionality is working fine on the Amazon or not. That is nothing but a black box testing. And here's the reason why it's black box testing. You have no knowledge of how Amazon is implemented, right? All you know is, hey, functionally, is it working the way it's supposed to or not? I don't care how you implement it. Okay. So when they do those testing, that's a black box testing. The intention of that is I'm going to treat the entire software as a black box, that I don't know anything what is inside it. I give the input, get the output, and all I care is the output matches what I'm expecting it or not. This is a lot of times done typically when you're end user. So a lot of all the manual testing that you do without an internal knowledge. So all of the UAT testing, they're nothing but a black box testing. Because your user don't care how you implemented what you implemented. All they care is it working the way I expect or not. Okay. Versus if you write the test cases with the knowledge of how the software is developed or built, then it's known as a white box testing. So in other words, if you're writing the test cases, knowing that, hey, I have 4 different paths to be taken in the software, and I'm testing each one of the paths, then it's white box testing, that you are writing the test with the full knowledge of how the system is implemented. Okay, so things are transparent to you as a quality assurance person of what work the developer has done. So all of the unit testing that the developer write, all of the system and integration testing that you write it as a quality assurance person, they all are nothing but white box testing, because you know what architecture they've used it. And you've written the test specifically to find the endpoint and integration point vulnerabilities. Then it's all the white box testing. Any questions for this type of testing?
So the black box testing, you don't have to write test cases versus white box and right?
No. So in a black box testing, you're also writing test cases.
Okay.
But you're writing the test cases based on your knowledge of the different scenario laid out in the requirements document.
Okay.
In a white box testing, you're writing test cases based on the scenario that you know can occur based on internal knowledge of how the system is implemented. Right? So like if I tell you, hey, it doesn't matter whether it's an NTR architecture or service-oriented architecture. The functionality is still the same, right? So you're doing it from a black box testing because you don't care how it's implemented. Versus if you write the test cases, then I know it's a service-oriented. I know that service needs to be tested. I know that service needs to be tested. I know this integration needs to be tested. At that point, you have an internal knowledge. You're not coming from a requirements point of view, but you're coming from how each of the function and capabilities are implemented. So that's the difference.
So a manual tester with no knowledge of coding can test, they cannot test code coverage testing.
So if you don't have a knowledge of how the code is implemented, you can't guarantee that I'm going to cover each of the segments in the code, right? So for example, all right, if you just say, hey, great. So if I do it, right, if I'm trying to determine what state tax I need to fill in, right? So if I write something like it's if resident, right? So if I'm an Ohio resident, then I file the tax, else do not file. So when I look at this code, right, I know there are 2 paths. So I have to write a test case to make sure if somebody's resident, this particular segment gets executed. And if somebody's not resident, this segment gets executed. Now I have an internal knowledge of how the system is implemented. And that's why I'm writing through these 2 different test cases. And it's a white box testing. Right? You're going to have a lot of those kind of scenarios throughout the code. And then when you write the scenarios to make sure all those things doesn't result into an executable path, that's what is white box testing is. Okay. Then there are different types of testing depending on the scope of the work that you're trying to test. So the third view is, remember we talked about the V model, right? So let's go from a bottom up this time. So the first thing you do is whenever a developer writes anything is that they perform unit testing. Okay. So the goal of unit test is to verify functionality of a specific section of the code. So you're not trying to like test everything, but you're trying to test only a small component of it. Okay. So when you look for that small tunnel vision and says, I'm going to take only this 10 lines of code and validate that they are working the way it's expected, that's a unit test. Because I'm taking the smallest unit and testing it. Who does it? Typically, developer does it. Okay, because they have an internal knowledge of how each one of the segments is implemented. And this happens way early in the development lifecycle. So this happens during the development phase of it. Even if I'm doing an agile, right? The developer is going to write and implement something first before they hand off you to say, hey, this piece is working, can you test it? But they need to say, hey, if I write all those if then else, are they working as expected? So they will do that first testing that anybody does it with the type of dynamic testing is the unit testing. Remember, I could have done static testing before, but in order to do a dynamic testing, I need some sort of system. And the first time the system is going to exist is when the developer writes that small segment of the code. So that's where this thing is that. Okay. Once they're done with it, they said, hey, all these small segments that I wrote, that each of the segments are working fine. Now I'm going to bring those segments together and see if they work in a unit or not. So that's a next level of testing is called an integration testing. That I have small pieces and I'm integrating all of them into together. This still happens in the development because I need to have a full knowledge of how all those small pieces are written. They're coming it together. Okay, so it's still done by the developers, but the only difference is that it happens a little bit later in the development lifecycle than the sooner, right? Because I'm writing small pieces. Now all the small pieces are working. Let me start bringing them together. So at that stage, the integrations testing kicks in. Still, no involvement from quality assurance person because everything is so close and near to the actual code. I'm going to skip this too for a moment and I'll come back to that later. So the next step is now that I have small functions are working, I'm going to bring them together in a system, right? To say, is now my system working fine? I've written down all its individual components that I've tested it in the integration testing, they work. Let me bring it as all of them together and does they work as a system? That's when you as a quality assurance person gets involved. Now that the system is ready, I can start testing the system and testing the functions. Okay. And this typically happens in the early phases of testing lifecycle. That's typically the first thing I do it is when developer give me the code, I'll start executing some of the system tests. So if you look into that V diagram, it's the third from the bottom. Unit test, integration test, now it's system test. Okay. And the goal for this thing is to start testing the system level functionality, not individual program level. So it's not that, hey, can I access the database and validate the users, right? This is, as a user, can I log in into the system? That level of function, it's testing. Then another type of testing is a regression testing. Now, think of it. Developer gave me a piece of code saying, hey, this part of the system is working fine. You go ahead and test it. So as a quality assurance person, I started testing it. And I found a couple of bugs. So I ran it 50 test cases. 2 of them failed with the bugs. I gave back to the developer and says, hey, here are the 2 problems that I encountered while I'm testing it. can you fix it? So developer will go, they will fix it. And then at some point they'll come back and says, here's the new version of the software. So now I'm going to do it is I'm going to make sure those 2 test cases passes, right? Because those were failed. So I'm going to continue testing those 2, just like what I would have done it, assuming that it didn't pass it. But then I also have to worry about it since this is a new piece of code, and you could have broke something that was working fine before. So I need to make sure that when you give me a new version, not only you fix the 2 things that I told you to fix it, but I need to make sure that you didn't break anything else that was working first. Right. So like think of it, right? When a plumber comes, you have a leak somewhere, they're trying to fix that leak. You need to make sure it doesn't cause something else to break, right? Same way. You need to make sure all the things that was working before in that particular segment, it's still working. So that means the test that passed it, you have to rerun that. And that process of testing the things that was working fine before and retesting is known as a regression testing. Okay, so this also is typically done by test team and during the testing phase, because that's when you keep getting the new version and you need to revalidate it. So the goal is this thing. Does it fix defect or it did not introduce any new problems? That's the goal for you to test it. Then the next step comes is a functional testing. Okay. Earlier you were testing it, hey, various components of the system are working fine or not. But once entire system is ready, you need to make sure, hey, is the function is working. So for example, in the Amazon world, that example that I gave you, the checkout is a function, right? But the checkout, does the checkout works? They said the developer may give and says, hey, you know what? Here is the checkout function. It works for everything but the PayPal integration. So you test it, all of them, it's working. They give you a next version where the PayPal is working, you tested everything. So now your checkout function is working. But from a user's point of view, checkout alone is not going to help them. They need entire, can I order an item and ship it? That's the big function they're looking. They're looking for ordering function. Well, is the ordering function working or not? So when you go from a system function, one level up, it says, now I'm not going to worry about individual component of the systems, but I'm going to worry about, can a system work as a holistically? Is individual functions are working or not? That's the functional testing. Now, in order to do some functional testing, depending on how you have broken down your functions, it could go across multiple components or it could be isolated within a component. So if it's isolated within a component, a lot of times your functional testing is the same thing as your system testing. But if your functions are spanning across multiple components, then that's a next level of testing. Okay, any questions? Okay, this is again, it's performed by test team, and it's can user do this particular task in the system? Questions? Okay, so let's go back to the 2 that I skipped. The sanity testing and the smoke testing. Okay, so think of it moment, right? So a developer was working on something. They give you as a tester, saying that, hey, this functionality is working, here it is, go test it. The first thing you need to do is it even ready for testing? Because a lot of times, most of the system is not made up of just one component. It's made up of multiple components. So when you think about a e-commerce system like Amazon, right? Typically, it's made up of multiple things, made up of a database, made up of a business logic aspect, and made up of user interface components, right? So if you look at the 3 tiers and higher architectures, right, everything are multiple components. So first thing you need to do is when developer gives you a new version of code is, hey, did he give everything that he needed? Is it even sanitary for me to start even doing a testing? Because if the database is not up and running, and they give you the other two P's and you're trying to perform a login, which requires them to go into database and validate, can you even do that if the database is not running? You can't, right? So at a minimum, the first thing you need to do before you even try to do any testing is, are all the three components that require for this system up and running or not? So you need to perform some sort of sanity testing or some quick check to see, is it working or not, right? So when you do that testing, that's called a sanity testing. And typically you do it whenever a developer gives you, here is the new version of code. Did they give you all pieces? Do you have everything of what you needed in order to run the testing? And it's usually done by you, but it's an early testing. And throughout the testing, because the developer is going to continue giving you a new version of the code.
Is it kind of like when they give you a new build?
Right. Every time they give you a new build, you need to make sure, did they give me all the components? Because they might have added a new component that you're not aware of. And in order to run it, does it everything work or not? Right? Because think of it, if not all the components are present, do you want to waste time in running the test and say that everything fails? Why everything fails? Because it's not sufficient for you to even up and running the system. That's why everything is failing.
So is it hard to create a test cases for this? Or?
No. It's not hard to create test cases, but you have to run that test every time they give you a new version, right? And it's not trying to test any functionality. It's trying to say, is it even same system that I can proceed with the testing? That's what this is, okay? And then there is another type of testing called a smoke testing, okay? So there are two parts of it, right? So first part is all components are there or not, right? That's the sanity testing. And second aspect of it is you have all the components, but are all the components functional or not? Okay, so that's a smoke testing. So in other words, is there anything that prevents you from proceeding with the testing? And this sometimes goes beyond the scope of just the systems. So think about it. They've put something on a remote server for you to test it, okay? But the network connections between your machine to that particular server is down and it's not available. Can you proceed with the testing? You can't, right? So smoke testing is essentially, are all the components up and running, including non-system components, so that I can proceed with the testing? So that's what it all talks about. Not only whether I have all the components, but are all the components start as expected without any error. That's what this is. Typically, like it's smoke testing, it's done whenever you get the build to make sure the build is working perfectly. And can I go and start doing testing or not? And it's also performed by testing team. So sanity testing is a small version. Often you will see a lot of times whenever they give a new build, people say, let's just do a smoke and sanity testing. So they kind of integrate both to make sure, is it good for you as a quality assurance person to proceed for the testing or not? Another things you will see it is, now it's getting a less and less nowadays. But in the olden days, with the mainframe and dedicated computing hardware, essentially people will shut down the systems at the nighttime to perform the maintenance. And then they will start the system back up early in the morning. So when they start up, right, the first thing they want to do is, did everything started fine or not? So they will run a sanity and smoke testing in a production environment with a non-destructive transactions to say, hey, can I go ahead and access all the pieces before my real customer starts coming in to do that. Now I know that with the modern day, the cloud and the newer computing environment, it is coming to a point where everything is 24/7. And therefore, there's no way that you're gonna bring that system down and then do that. Typically, you do it is whenever you're ready to release the new version of software, you kind of try to run those things and says, hey, is everything back up to the new version of the software or not? Right? And that same practice is now getting carried from a production environment into test environment. Whenever a developer gives you a new version of the code, is everything working or not? And that's where the smoke and semi testing plays the role. Okay. Any questions before I get into the other aspect? Okay. So think about progressively in that V cycle, right? In the V-shift testing that we talked about. So things is moving from unit tests to integration tests to the system test. And at some point, you're going to say, hey, all the functionality is working fine that's expected manually. Now, the question comes in is, if it's going to be a system where a lot of users are going to be logged in, the question is, when you test it manually, you test it as a one user only and you logged in as only one person. So there was no load in the system, quote unquote. But in a real production, you said, hey, there's going to be 500 people logging at the same time and performing the functions in the system. So will all 500 will get the same response as what you got it when you were doing it individual one-off testings. Right? So you have to run some sort of testing to say, hey, when I put a lot of demand on the system, does the system still respond the same way or not? So that mindset is considered, hey, I'm going to do a load and performance testing. Does system still perform the same way under expected design load? Right? So when you do those testing, they're non-functional testing, right? Because remember, you already tested that functionally everything is working. Okay. Another aspect is if some functions are not working, is it worth for you to do any load testing? Not, right? Because if you can get it working for one person, it's never going to work for 500 people. So let's make sure it works for one person. That's a functional testing. If that is working, then I'm going to go look for it. Will it now work for 500 people? Okay, so that's essentially a non-functional, and it's focusing on based on the capacity and responsiveness of the system. How many people it can handle it without degrading the response times. Now, the whole goal of that is, can system perform under expected design load? Okay, so that's the whole goal. Now, typically it's done on a really late stage of testing cycle because you have to have all the functional system working before you get into that. And a lot of times it's performed by testing. However, as Herschel mentioned, this requires some additional and different skills. So in a big corporation, what you're going to see it is a dedicated team to perform the load and performance testing that have additional skills. So they can definitely do all the manual testing, but they also have some sort of programming background because you need to write scripts. You need to write and utilize some additional tools. And sometimes you have to write the programs to go ahead and perform those execution, right? Because another aspect is if the system is supposed to work for 1,000 users, you can't afford it when you get in this test and says, okay, I'm going to employ 1,000 people and going to make them sit at the terminal and then do that. Think about the cost that I need to incur. Hey, I need to hire 1,000 people. I need to have 1,000 computers. I need to build a network, all those 9 yards. So typically it's done through simulation. And so you add additional computers on compute powers, but they all will pretend like it's different users coming in and pounding the system. Okay. So that's a load and performance testing. Any question on this one? Okay. So the next set of testing is called stress testing. So load and performance testing allows you to answer a question. Does system work under expected load? Okay. So I know that, hey, my user called it that only 500 concurrent users, so 500 users. Does it work with the 500 users or not? So if I'm trying to answer that question, that will be load and performance testing. But if I'm trying to answer, at what point the system is going to break. Okay. So if you say it's 500 concurrent users, okay, how many more users I can put it before it breaks? So I incrementally increase the load till you reach to a point where the system is no longer responding the way it's expected, or it's no longer functioning as it's expected. So that's sometimes known as a breaking point. And when I do the testing to figure it out, what is my breaking point, that's a stress testing. Okay. Let me ask you a question. As I mentioned, like I'm a little bit more a science nerd. How many of you have seen the movie called Apollo 13 or know about the Apollo 13? Okay. So it's the real story of the 1970s when NASA was sending people to the moon. On Apollo 13, when they kind of sent the people to the moon, halfway going to the moon, there was a system malfunction and part of the system blew up. Okay, so there was no way with that crippled system that they could actually go and land on the moon and then bring it. However, the biggest issue was not going and landing on the moon at that point. When the systems and the aircraft blew up, is the people were like a day and a half away from the moon and day and a half away from Earth. How do you bring those 3 astronauts alive back into that? Right. So at that point, they kind of employ a lot of stress testing. And you can see a little bit on the movie also. It's not about what the system is designed for. It's at what point system is going to break it. And they made sure that they pushed the system to just a notch below that breaking point to bring all those 3 astronauts live. How they shut down the systems, how they brought back the systems, it's all around the stress testing. Okay, so that's an example if you really want to see it live, stress testing of the software and the hardware and craft. But this is typically, you do it at what point it's going to fail. And this stress testing is live done on most likely any of the systems which are mission critical systems. So 911 systems, when I was in a telecom firm, we will do regularly stress testing for any new hardware that we'll deploy for 911 system. Because we need to know at what point it's going to break it. So we can predict it as, okay, how much traffic we can handle it without breaking that system in the event. One of the perfect example, when 9/11 happened, pretty much entire load in the New York grids went it down. So you couldn't make a single phone call to go through it. That's a classic example where some of the capacity that was planned was way overutilized. Right? Because most of the phone systems are planned at that at any given point, only about 20% of the people will be utilizing that systems. When that 9/11 happened, the thing spiked up all the way to 100%. You couldn't handle the 100% because that was not what the system was designed for it, or the hardware was stressed enough to handle that. You could do it to about 30–40% of the people, not at 100%. Right. So some of the times you have to do those kind of critical systems that you're handling it to figure it out at what point it will break. Now, this is very destructive testing because you're breaking the system. So you can't do it in production. You need to almost have a good model or identical production in a test environment in order to do that. So these are both load and performance and stress testings are expensive. So a lot of times you will see a lot of non-mission critical systems, they don't do this type of testing. They are typically reserved for only for certain categories of systems that you're building. Okay, any questions on this one? So these are, you will not find very commonly that these two are done. Then you talk about the user acceptance testing. So now that you have tested the system, that functionally it works, you've tested non-performance aspect that, hey, it can handle 500 users on the load. So at that point, from the development team point of view, when I say development team, I include both quality assurance people and the people who are implementing the systems. From their point of view, system is ready for the users to use it. More often, the users still go through their own testing. Once you give it, hey, this system is working good. Think about it, right? So if you're building a house and you're purchasing a house, right? So even though the constructor has gone through it, the contractor has gone through it for everything, the county has gone through all the testing, but they still make you to do a walkthrough in the house, right? To make sure is the final functional requirement from the user's point of view is done before closing the house. And at that point, they're thinking of not necessarily nitty-gritty detail of does every plumbing and everything works or not, right? They're just doing, did you build the house that they are expected in the future? Did it have this many bathrooms? Did it have this many rooms? Are the rooms situated that? Does the windows are like that way? Those kind of things they do it, right? So as a user, you're more or less kind of kicking tired of the functionality and making sure it is working. Same thing in the UAT. If you recall it in that stack, the last one on the top was the UAT, because that's one which triggered everything to start it. So I have a requirements and what are the acceptance criteria? So they will go ahead and do the manual testing. A lot of times users may come back and say, hey, you know what? I'm not skilled enough, but hey, quality assurance people, you are skilled enough. You know the system. You and I talked about what features and functionality. Why don't you test on my behalf? Tell me what all things you're going to test it so I can quickly review and say, yeah, good. Or I can tell you, test this also in addition to that. And then show me the results that everything is passed and we are good for that, right? So this UAT testing could be either done by business user. They may be savvy and they say, hey, you know what? We're going to do it ourselves. We'll test it to make sure you've met everything. Or sometimes they just say, hey, testing, you do it for me. And then we'll look at that results. So the whole purpose of this thing is to answer, is the system usable by user? And now, is it sufficiently working to a point where I will write you a check and says you did your work? Okay, so that's the UAT. And this one is all manual and all black box. Okay. Now, there are a couple of other type of testing that you're going to see in addition to all that entire spectrum. Okay, one of the type of testing is known as a backend testing. So remember the example that I talked earlier for the Amazon, right? So there's a payment gateway. So at the checkout process, I have to give the payment. And that payment could be any of the number of banks or any of the number of ways, right? So at Amazon, a lot of times, they kind of give it out to MasterCard or Visa card, right? They all have their own gateway. So if you provide a Visa card, it could be issued by any number of banks, but all of those banks go through the same gateway that is kind of provided by a company called Visa. And so essentially the Amazon builds the gateway to say, I'm going to go check it with that Visa gateway. I'm going to give them, here's a card number, here's the amount, here's that. And you validate that for me, whether it's a valid card or not, so that I don't have to go to 500 banks, right? So that entire thing that from Amazon system that goes to the Visa gateway, there's no user interface, right? You can't just go and say, hey, I want to test that Visa gateway manually, right? It's from a system to system interaction. So a lot of times you build an API and says, I'm going to test that backend system. As a tester, there's no user interface. I'm writing some sort of tool or I'm writing some sort of code to go ahead and test it, whether that particular system or function is working as expected or not. Sometimes I kind of have to test it is you perform this transaction and it says that, hey, transaction is successfully completed. I need to go into database and make sure that all the data is populated correctly in the database. So it's not just the front end is telling me the transaction is processed successfully, the database also reflects that data. So then in those scenarios, I have to go directly to the back end, call the database and validate that this thing has happened. So when I do those kind of testing, it's known as a backend testing. Right? So you will see it like example as system to system interface or writing directly to transactions. For example, when I'm trying to do a transfer from one account to another account some money, the UI said that everything is transferred. I need to go back into the database and says, did the balance reflected that actual the transfer occurred or not? Right? Because sometimes I may have to do it because they may not have all the front end feature available and implemented yet for me. So then the only way I can validate things is working is to go in the backend system and do it. So that's typically you do it during the testing phase. A lot of times testing does that. That's part of the reason why one of the things I recommend in terms of skills for a quality assurance person is to make sure you have a basic minimum SQL skill so that as you're testing the system, you can actually interact with the database and validate things that is happening. Okay. Any questions so far? This keeps coming. This one.
So I have a question.
Uh-huh.
Is there any type of hierarchy which we need to follow to perform these testing? Like this type of testing should be performed first, or we just need to write test cases according to each testing?
So there are two things you need to think of it, right? Is first you need to understand what kind of testing responsibility is going to be performed by who, right? So for example, as I mentioned, typically unit test and integration test is developers' responsibility. So they do it. But you also need to understand it is at what point they will be done with that. Because unless they are finished with that testing, there is no value for you to do any system testing. Because if the functionality is not even working at the smallest denominator level, why even you're wasting your time? Because you know exactly it's going to fail, right? So in terms of time-wise, you want to make sure that there is some progression, right? So, and the key thing is in that V model. Look at that V model and says, make sure before you get into the next phase of testing, the previous phase of testing is successfully executed. Now, for the planning wise, you don't have dependency, right? You need a requirements and then you can start drilling it down UAT and then system testing. So you can do that irrespective of that. The more important aspect comes in is when you're executing it. That's when you need to make sure that you're following those cadence. Okay. And again, as you go through it, right, regression testing, every time they give you, you need that. And regression testing could be at the system level or it could be at the UAT level, either one, right? So once you get into that phase, then you're going to find yourself that you're executing different types of testing constantly at the in parallel. Okay. Now, most of the times that you're going to interact is now going to be a web application. So I would say is that till probably early 2000, if you're in the quality assurance world, a lot of times you will be dealing with the application testing of those applications which are installed on people's machines. Nowadays, I would say sort of majority of that, if not over 99% of the development is happening in the web world. Okay, so any businesses that try to put for things, it's either going to be on the mobile or it's going to be on the web application. So the only two variation that most likely you're going to hit it when you go through it is the mobile applications and the web applications. So we talked about a few things, but there are some additional things that I want you to be mindful of it when you're writing test scenarios for the web applications. So first thing you need to think about is when you're doing a testing of web application is it usable? Is it friendly for me to do it? So now there is a whole branch of computer science world that's been started in the last probably a decade or so, known as a user experience and the UI, UX, and CX development, right? Which is whenever you're building a systems, you need to think it from a user experience point of view, from outside in, right? Gosh, how it's hard to find an example. If you're building a system and if it's not a user friendly, it doesn't matter how many great features it provides it. Most likely people are not going to use it. Okay. The perfect example I will give it to some extent. If you use Microsoft Excel, I don't know how many of you use it. Okay. There are tons and tons of features in Microsoft Excel. Not all of them are user-friendly. You need to know special formulas, you need to know special ways and special programming in order to use those features. Okay. Only about 10% of your population of Microsoft users are using it. Versus if you go into Google Docs, right? And this is something that became a lot more forefront now that with the COVID situation and everybody's working from home. And I will say my first interaction is with the kids, right? Because I kind of volunteer with a whole bunch of youth community, both in Indian as well as in the other communities. And I kind of mentor and work with them a lot of times. So if you go into Google Docs or Google Spreadsheets, right, the collaboration is a lot more easy. Like there are 10 people working on the same sheet, on the same document, same time, and they can see clearly who is working what, right? And it's web-based, right? It's a perfect example of usability. It's much more usable if there are 10 people collaborating on that, versus if you have to do the same thing in Excel, you have to have one person doing it, saving it and closing it, and the other person opening it up. And if there are two people who open at the same time and then update it, those versions are not going to sync up. So if I have to now collapse it all into one version, then somebody has to do manual work and says, what change we did what? Here, what did it? Let me go ahead and update now. That's an example of usability, right? How usable is one product versus another product. So when you go and building it in the web application, the first most important rule that you do it is that usable for the user. If there are certain things that you want them to use it, but it's hidden 10 clicks away, chances, and the stat shows people lose an essentially interest in using any features after certain clicks. No matter how good you build a feature, they're never going to be used. So when you build an application, you need to test it and says, is the feature are usable? That means, can I navigate to it a lot more easy? Is it easy for people to understand, or it's complex to do it? So that's one aspect of the usability testing. A lot of times you will hear it A/B testing for the systems. Okay. Then you go into the functional testing, which is the system do what it asks from the capability point of view do, right? Which we talked about. Everything about testing we talked about is all functional testing. Then, in the case of a web world, you're going to worry about compatibility testing. Okay. So when you're building it in-house application, it's going to run on your own employees' machines. It's a lot more known environment. Like you know that, hey, what versions of the browsers you use, what type of browsers you're using, everything is known, right? So all you worry about is testing that. But when you're building a web application and deploying out to the mass number of users to use it from whatever the environment they are working on it, well, some of you might be using Mac, some of you might be on Windows, some of you might be on the tablets. And each one is going to have a different browsers. People may use Chrome. Mac users use Safari. If I'm using a tablet, I might be using completely different operating systems and whatever the browser that does. Even within the Chrome, right? Some user may be using a really old version of Chrome. Some might be using most up-to-date version of Chrome. And some might be using Edge. So now, all of a sudden, I have to deal to make sure the functions and the system that it's kind of presented to them works exactly the same way in all the browsers. In some cases, it doesn't, right? So often, how many times you hear it, hey, if I go to that site, it's better to go into Internet Explorer or in Chrome or in Safari than this thing, right? That's an example that, hey, the system doesn't work as expected in one version of browser to another version. So as a user, they may have different versions. So that makes your job as a quality assurance person a little bit complicated. Now you need to have a conversation that says, okay, tell me what browsers and what versions this application needs to work on. And you need to test in all those browsers and all those versions. So it's the same test cases, but you need to make sure it works in on all of that. One of the perfect example is people tend to build original the application with a lot of function and features with a right click of the mouse. When you go into tablet world, there's no mouse, there's no right click. So all those feature and functionality that you build it, that you can do it on the right click, are no longer accessible. It's not going to work, right? So that's a compatibility testing. Does my application work and behave the same way across all the expected browser and versions? Because you can't go and predict it 5,000 version of browsers and you can test it, because then you'll always only be doing testing with every browser that is possible. So one of the key things is that as you look into the requirements, that you start identifying if it's a web-based application, you should ask the question, hey, can you tell me what all browsers your user base is going to use it and what versions are going to use it? So we can narrow it down and says what exactly we need to test it for your application. Then we talked about the database testing, right? Database manipulation. That's a backend testing. Another part is security testing. So now if you're like it's saying that, hey, I was going to access the application from the confines of a company's premises, then you know, hey, there is no network connected outside. You have the network security and everything. But if I'm doing your home banking from using online tools, now all of a sudden I need to make sure that all the path from the time that data leaves the bank server till it reaches to your machine, it's secured, right? And also, when you say you are XYZ person and you log in, I have an ability to validate that it is really you and not somebody else pretending as you to log in, right? So a lot of times you see two-factor authentications where you log in, right? And they will prompt you, hey, where do you want me to send the text message? They will send a text message to the device that is registered, and then you have to enter that code to validate that, yes, you are the person who has the device in control and who has the same credentials that is logged in on that. So you need to worry about that security testing. And not only from the login point of view, right, but from a data encryption point of view. We talked about SSL the other day. You need to make sure if somebody's tapping into the wire, they're not actually getting all the data. And the traffic is not meaningful for them unless they have an encryption and decryption piece. So those are some of the things that you need to think about it. And the final thing you need to worry about is performance testing. Like a lot of times you will see if people say, hey, on a web application, now there is an additional dimension is set it up, is your network connection, right? So with all of this COVID and people working from home, including the school, sometimes you say, hey, the network is congested and I really don't get that much response. I click it, it takes it like 3-4 seconds before that click is recognized and then perform some actions, right? That's a performance testing. And now you need to worry about it is testing it is what is the slowest connectivity is going to be from the user's point of view, and does this function and feature works on that slowest connectivity. So that's the kind of performance testing. Okay. Now, when you're building a mobile application, there are a couple of additional things that you need to think about it, is the connectivity, right? So when I'm doing it just a plain web application working from my home, chances that I still have a sustained connection. But if I'm driving it on I-70 over 70 miles an hour, and I'm kind of connecting from one tower to another tower every so often, is my connectivity kind of maintained it? When I lose the connectivity, do I establish and get into the same session that I was working earlier before? Is it critical? And can I test that I do not lose my login credentials when you move from one tower to another tower for connection? right? So those kind of testing that you need to think about it, validate it. Okay.
Can a manual tester do that? Security testing and performance testing?
So there's to some extent of manual testing can be done both security and performance testing. Security testing, you can do all, majority, I would say about 90% of that, you can do manual also. The performance is one, if you're doing it on the slowest connectivity performance, then you can still fine tune and say, instead of connecting this, now I'm going to change my settings to be this and expect that. So you can do some sort of testing, but then there is always robust network level testing that people do it. So for example, if you, like it's a working from home, right? Then you say, hey, sometimes why my network is working slow? You can go to the speedtest.net, right? And you can go and say, hey, what is my connectivity from my home to that? So you can figure it out. Hey, is it my connectivity which is slowing everything down? Or is it actual application which is slow? Okay. Yeah. Any questions so far? Okay. So this is what we're going to do. Typically, we do an exercise starting here, but I'm going to, because we are so close and I don't want to take a lot of times to show you actually the manual work that you will start doing it starting tomorrow. So I'm going to go ahead and skip the exercise 6 for now. We'll do first thing in the morning tomorrow. I'm going to talk about the software defect management. So this is the bug tracking aspect of it. Okay. So this is the last theoretical portion. We'll finish it up before getting into heavily now what you will be doing day to day at the work, and we'll actually practice all of that. Okay. So when you start getting your software into the test environment, you start testing the software, you start identifying the bugs. And sometimes you can start using the bug tracking system even before that, right? When you start looking into the requirements document and you start identifying, so you may use the same bug tracking mechanism to communicate with the bugs around the review process in the analysis phase. Okay. So let's talk about the software defect management. The whole goal is to understand how that entire process is managed. And there are a lot of different tools you can do it, or you can do it manually. But it's more about what is the process and how it works. Okay, so think about it. Defect is nothing but a non-compliance to the requirement. That's the simplest way you can put it. Is that any behavior of the system that is not in concurrence with the expected behavior from the requirements document. Okay, so anytime you get an incorrect or an unexpected result, that's essentially contributes to defect, or your system behaves in unintended ways. Now, one key distinction I want you to understand is lack of requirements or missed requirement doesn't constitute defect. So whenever you're looking something is a defect or not, you have to look from the context of, is it complying with the requirements document or not? Okay. So if your requirement document doesn't say anything at all about it, that's okay. It's not a defect. Okay. So that's where that 3C and a T comes in. And that's what this one is talking about, right? Unambiguous behavior due to the lack of requirements is not a defect. Okay. So this is a life cycle. Go this way. So whenever you start testing it and you say, hey, the results that I got does not comply with the intended behavior as specified in the requirements document. At that point, you start with this phase. Yeah. There you go. That's when you start at this phase. You identify that defect is found. Okay. Once it's found, you start logging it, whether it's manually in some sort of Excel, or sometimes you have a software that allows you to track the defects, and we'll look at both of those a little bit later. But you start with it and create that, hey, now this is a new defect. I'm going to set it up as an open defect. Okay. One of the first thing that happens is as soon as you open a defect, that defect needs to be assigned to somebody to look into, right? To investigate, hey, why this is a problem. Okay. So typically, if you're working in an agile world, right, you very well probably in a small team working together, you know who is working on that. So you can assign directly to that person to look into it, whoever has built the solution. Okay. If you're working in a more complex product where there are many agile teams and you don't know where the defect needs to be assigned, so typically you set the defect is to be assigned, and somebody either at the project level or a product level is responsible to take that defect and assign it to appropriate right team. So right person who can look into it. So if it's a bigger team and you don't know who all is working and who built it, typically there is always a process. So you don't have to worry about it. You just say, hey, there is a new defect and it's unassigned, and somebody will assign it. A lot of times in a big companies, they set it up a queue system where you identify a defect and you know, hey, I need to assign to that particular queue, and that's all you need to know. And then somebody, whoever is managing that queue, and remembers who is going to look into what. Okay, so that's an assignment aspect of it. So it's essentially at that point, you perform this task. The developer is going to assign to look into it. The first thing they do it is analyze and says, hey, is this in compliance with what is expected in terms of intended product behavior? If it is, they can say it's not an issue. It's your understanding is not right. It should be this only. And here is the document which says it should be this, right? So at that point, the defect gets rejected. You as a developer, as a quality assurance person, then need to understand what changes I need to do it in my test case to reflect that expected behavior to be what should be. Okay. But at that point, the defect is closed. It's now me as a developer, as a quality assurance person, need to fix it. It's not in the software. If it is a problem, then it goes down to this path. Okay. The first thing they just say is, what is the issue? So developer performs the analysis, and then they essentially update the code, whether writing a new code or fixing the existing code, to fix that defect. And once it's fixed, they will create a new version of the software. And then they will come in and they will flag into the system that this defect is now ready to be tested. So in other words, it communicates that, hey, I already know what it was. I fixed it. Here's the new version of software. Now, at that point, right, you may have a process where you may have a cadence that says, hey, every Monday we're going to perform a new release of software. So there may be, they may collect it together and then give you, here's a new set of the version. Here is the 15 defect which is fixed type of thing, right? So time-wise, it could be depending on the cadence. But from the process point of view, once it's fixed, I'll set it up as a to be verified. And at some point, the test team will pick it up back and retest it here. Okay, they will use the same test, original test that they used it to find the defect. They will rerun that and they validate whether it's fixed or not. If it is fixed, then they will close it. If the issue still persists, then they will go ahead and push it back and says, wait a minute, you said it's fixed, but it is not. Here is the result. Here is the issue. And they reopen it and then point it back to the developers to go back and look into it. Okay, so that's the life cycle. Keep going through that loop till you verify it and close that. Any question on the life cycle? Okay. So that's the life cycle, and the whole goal of managing all the defects in the system, the entire process is known as a defect management. Okay. And it starts with as simple as that. The first goal is to prevent any defects. Okay. So you should have a good review process in place that will allow you to catch those things as early as possible. Or you may have a good standard so that developers can follow that standard, there's no more defect created. If most likely, right, you can never prevent all the defects 100% of the time. There will be a scenario where certain things is going to fall through the crack. And if it does, then you should have a mechanism in place that allows you to identify that defect as early as possible. Like, remember what I talked about is, if your foundation has a problem, you don't want to find that after all the houses and everything is built, because that'll be a wrong place to find it. You want to find it as before the frame goes up onto that foundation. And then once you identify that defect, your goal is to say, how can I minimize the impact of this defect? Right? So when you're looking at defect management, it's not just only about finding it and fixing it. It's that entire process of what you can do it to give the feedback loop so that progressively you're finding less and less defect and things are getting much better in terms of quality wise. Okay. Here is a data of how much defect costs. Okay. If you find a defect in a requirement phase, so if something was inconsistent and you catch it up in the requirement phase, the cost of fixing that is very minimal. It's about $1, right? And then this is a relative terms. So when you think about it, right, the actual time you spend it at that point is, hey, I found this, let's just go have a conversation with the user. And then they will quickly identify what needs to be right answer, and then it's done. There is no software to be updated. There is no testing or retesting needs to be done. And there is no impact to any of the users because the system was not there. Before anything happened, I fixed it. As you go into the design, it's a little bit more expensive, but not significant because there's nothing is built. When you go into the implementation, right, now the cost starts escalating. That I have to rework, right? I have to rewrite, potentially I may have to retest certain things. When I go into the test environment, same thing that would have cost $1 here, now costs $10. Because A, I have to recode it, I have to retest it, I have to go through the redeployment from one environment to another environment, right? And potentially that defect may have an impact on the others because that means I have to do a whole bunch of regression testing also. So I'm not just now focusing only on that defect, but I'm focusing on the other thing that could have broken and retesting those things again. So the amount of effort I need to put it compared to the coding environment is significantly higher here. So, but if I'm a tester, quality assurance, and I didn't catch any of those defects till actually it goes into production, now it's a big problem because A, my users are impacted. Potentially there is a financial impact. So not only I have to fix with all these things, I have to deal with this financial impact. And I may also have a reputation impact. Okay. So I don't know if anyone of you heard it early last year, there was a breach at the Equifax and there are 300+ million people who were impacted. Think about it, the impact of those defects. It was a security defect, right? So somebody could get into it, you didn't test it sufficiently. So somebody could get into your system and grab all the data about your customers, which are sensitive. They had to pay about $120 worth of services for credit monitoring for all 300 million people. That's a cost of a defect. Think about it. $3.6 billion. If you would have found that, do you think it would have been $3.6 billion cost? Won't be. So that's an important data. That's why you try to find it as early as possible so that your impact is minimal. So here is a high-level defect management process. Okay, so what you saw is an individual defect lifecycle, but that doesn't happen in isolation. You have to think it from a broader point of view. So what you saw that was a defect discovery mechanism. Okay, and to some extent defect resolution. So it was only this to block. Now, when you think about the overall defect management, you have to first start with preventing the defect, because that should be your goal first. So this is where you look into it and says, hey, what mechanism I have it in place to prevent the defect? Right? One of the simplest mechanisms that we used it was the document review, right? The requirements document. Let's just make sure both the developer and quality assurance person looks at it, and they can identify the issues, and then they can flag it, and then it needs to be fixed. Right? Once you have that process in place, you can create a baseline around it and says that every project should do this 2 types of reviews before they go into the development. Make sure you have a requirements review with the user, and make sure you have requirements review with the development team and quality assurance team. And everything that is identified there has come to a resolution before you can start developing. So in other words, it's not just enough to do the review, but you need to conclusively show that everything that was identified as an issue in that review has been addressed. So that's the baseline process that you can say that from now onwards, that's my path to that. Great. Then they build the software, and they said, oh, you know what? Despite that baseline and despite that process that we had defined it and the rules that everything should be addressed, we're still finding the defects. So how are we going to find it, right? Well, I'm writing this test case, this type of test cases, and that's what it's contributing to finding that. Well, what it takes you to resolve those defects. Once you identify that as, hey, you're constantly collecting those reports, that, hey, this type of test cases are identifying this type of defects, they go back and look and says, can we do any process improvement around it? So let's say most of the issues center around the performance, right? And all the test cases were, hey, when I was trying to do it, performance this, and when the code was built, I lost 2 days because everything was failing it. Right? They may just look at it as, hey, how did you fix it? Well, we had to fix it in an environment. We had to rebuild it. We had to run this test to make sure everything was working fine. Well, let's just go ahead and say, can we do something recurring? Oh, yes, we can do it. We can just, every time the code is released, make sure it meets this and this requirements, so that the testing team does not lose 2 days and don't find those issues. And they can go back and say, you know what? In order to prevent the defect, now we need to institute not only just the review, but every time you perform a new code release from development to test, you have to follow this standards. And that becomes a new baseline. And then you look into, okay, ever since we instituted that particular process, are we still seeing these issues or not? You see, that's how it's constant feedback loop, going into it and constantly making it. So this essentially helps you process related metrics. So if you think about it in the test cases and test plans, I was identifying the process related metrics. This helps me with that. Versus this segment only, which is this 2 segment, essentially, this is where most of my product related metrics is going to be centered. Because I'm able to find a defect, I'm able to fix it, but what is the average time it's taking it, and all those things. Okay. Now let's talk about, when we talk about defect tracking. So once you identify a defect, what kind of information I needed in order to address that defect, right? So all that information is known as the defect tracking data. Okay, and there are some manual ways to do it, but there are some additional defect tracking systems that you can do that. And when we look into a lot of newer development tools, they are more like it's complete lifecycle management tools. So they allow you to do the development, to do the testing and defect tracking all into the one tool. So when we look into Azure DevOps, we'll show you how everything is integrated into it. Okay, but essentially, the whole purpose of any defect tracking is to get as much detail recorded into the system as possible. So you can perform the analysis, you can perform the improvement aspects of it. Excuse me. So what are some of the information that you collect, right? So typically, if you're tracking into the system, you do the ID, which is typically a system generated unique numbers. But us as a human, we can't keep track of the numbers all the time. So there is a human readable mode descriptor, the defect name and the type, right? And you can have different types of defect. Could be a cosmetic, could be something which is a infrastructure related, could be a software related, could be a process related. Okay. Then you also identify, how did you find that defect? What was the source that helped you to uncover that defect? A lot of times when you're doing a software testing, it'll be some sort of test cases. It says, hey, while I was testing this is how I encountered. Then defect severity and priority. Remember the test severity and priority we talked about? The same thing applies at the defect. How broader the impact of that defect is, and what is the priority in terms of user's mind, which one needs to be fixed first, because it's more important from the business point of view. Then the defect status, we talked about that entire life cycle from the open all the way to the reject. Then you also capture the date and time. So when did I open the defect, at what time? Okay. And you also track it, date and time stamp, every time somebody changes the status. So you can figure it out how long it was waiting it to be fixed versus how long it was waiting into the to be verified status. Then you get additional detail in terms of, hey, what were you doing as a tester that created that defect? Can you just say it's, hey, I was doing this tab and this tab, and here's the screen capture of what it showed me as an error. A lot of times when you're going to some website, right, you get either 404 or you will get some sort of backend errors that doesn't make any sense to you. So you capture it and says, this is the error that I got it while I was doing this task and this steps. And this is the data that I entered. Okay. So all of those information it gives you. The stage of origin, you can, if you are a good process-oriented company, right, you can figure it out. Hey, this is in the requirement phase, in the design phase, development, testing, or in production, right? So you can just say what stage this defect originated and track that. Obviously, we talked about the person who's going to be assigned. Then here's the defect priority. It's essentially more or less same thing, right? Is it the most important defect that I need to fix it first? Because think of it like it's a developer. If they get 50 defects, they need to prioritize this, which one I'm going to fix first, right? So they use the priority level within the defect and just do it. And a lot of times people just say, hey, between the combination of priority and severity, there are rules. Here is what you should work on first. Here is what you think should be testing and fixing it first. Right? And here are some examples that you can see it, whether if you're trying to, like, it's one of the example of the defect priority is highest. If I'm using it a banking systems and I'm performing it a transfer function where I want to transfer the money from one account to another account, and that thing is not working. It is taking from the origination account, but it's not updating the target account. That's a big issue. It better be fixed first, right? Versus, hey, once the transfer is successfully completed, they don't give a tracking number that allows them to view the transactions. later on. Well, that's a missing report. The work is done, you can still go into the database, you can still validate it. That may be a lower priority. Same thing with the severity. If I can't access certain functions, that's a big problem. Versus I can't see a background color updated on our page. Okay. Then we go talk about the reports. Remember it says, as I progress it in the development and the testing cycle, I need to provide, hey, how my work is progressing, right? Same thing we can do it while you're doing the testing. You can provide it, hey, how many new defects I discovered today? How many defects were fixed, right? And where exactly the defects were located. Are they in the security segment? Are they in the create new credit application? Are they in the lender segment or a dealer segment? And here is an example. Okay, this is very small number of data that I kind of squeezed in. When you look into the actual defect tracking systems, there's a lot more information that they collected. Okay, so this one is just tells you, hey, what is the status? Which segment or component that defect was found? What is the severity? What is the priority? When it was first created, when it was last updated, and a little bit of description. Just by looking at it, right, your business gets a sense and it's, hey, look, we have so many high and critical defects which have been open for a while. What's going on here? Do we need to address it? Are we in jeopardy of not meeting the timeline to deliver the software? And the last thing that happens is every time you find a defect, you need to perform some sort of impact analysis. Okay. And that's going to tell you how important that defect is, or can you live with that defect for a while, right? So some of the things that you identify is what is the area, or like it's how big that impact is. Sometimes you get the defect into the core component, and that impacts all the functionality. Then you say, hey, you know what? I better fix it because it's impacting everybody. Versus you find a defect, it's in one of the components, and you can say, hey, you know, there's only 10 users who wants to do that. Versus that it's 5,000 users who are performing the other task. So the overall impact from the business point of view and a user point of view, it's minimum. But what if that 10 users are creating a government mandated reports that you need to provide as a company, right? Because all the financial companies, all of the regulated companies has to provide those reports. And if you don't provide that report, every day you delay it, there are huge financial fines associated with it. Then all of a sudden, even though it's 10 users, it's very important because I need to address it, because the financial impact from the business point of view, it's higher than the number of users who are using the system. There are regulations both in the health industry, communication industry, and financial industry that if you don't meet it, the fines are in the tune of millions of dollars a day. Right? So that's where you start shifting the focus. You know, I know there are 10,000 users there, but the combined cost of that 10,000 users is only $100,000 a day. I'm paying $10 million of fine here. This needs to get fixed now, right? That kind of impact analysis you need to do it is what defect is causing you, and what is the financial impact, and what is the usage impact. Okay. Also, part of it is if it's not live system, what is the impact of that defect in my overall timeline? Is that defect now going to cause me not meet my end line to delivery? Okay, any questions? So that's kind of a high level overview of what the testing is, how do you manage the defect, right? And what is the basic software development and infrastructure process. Now starting tomorrow, so this is what I would recommend. You don't have to have a computer tomorrow, but I would strongly recommend if you have one, bring it. And it doesn't require whether you need a MacBook or Windows. What we're going to do is we're going to start the process of how do you write the test case. So how do you take a requirement and you start building a test case to validate, is this requirement fulfilled by the system or not? So that's the process. So that's about 70% of workload that you will be doing when you go into real world. It's taking the requirements, writing the test case and testing it. That's all majority of your workday will involve. So that's what we're gonna get into it. And we're gonna get into the process of how do you think about it? Just like what we did for estimation, right? Don't come up, what is the proper process? What are the things that you need to think about is when you build it? We're gonna go through that. Okay. So one thing strongly I would recommend is between now and tomorrow, if you've not had an opportunity to read through the requirements and the design document one more time, since we talked on Thursday, finish reading that. Okay. So, and bring your pen, right? Pencil, paper, notepad, whatever you need, because we're going to start doing it. So we'll do both some exercise together as a group of 2 or 3 people, as well as we'll do some individual. Okay, so we will have a forum where you will also start learning from each other, start having a discussion. Hey, I'm thinking this way, why it's different. Because if you notice a trend, right? Every time you have certain set of information, people have a different viewpoints, right? So you need to, in the real world, you will get used to having that different viewpoints and talking with the team and coming up to a conclusion, right? So having that process, not only just whether I'm right or you're right, it's what do we agree on it? That's going to be a key process as you go over to learning it into the real world. Okay. That's all I have it. I know it's a little early today, but we're going to compensate. Last time I had to hold you like 10 minutes past the hour. So we'll take a break there unless you have any questions. Okay. Any questions online?
No.
All right. So let's call it a day and let's focus on making sure we are ready for tomorrow by reviewing those 2 documents. Don't forget, I mentioned that you should also, between now and Thursday, finish reading the test plan document. So it will give you an overview of what it means, system test plan, what are the scopes and so on. Okay?
So they are bringing computers tomorrow?
I recommend it. I said you don't need it, but it'll be easier if you have it on computer.
That's right.
At the later stage, when you want to put in the tool, you can cut and paste it.
Yep.
Okay.
Real work starts tomorrow.
The real work starts. I'm done with standing up here for 4 hours a day. Yeah.
Excuse me, I have a question. Like, is it possible to get the Thursday recording video to my email?
So Harshal will send you a recording as soon as it becomes unavailable, because we are recording this into the cloud. So it takes Zoom a couple of hours for them to process and send us a link.
Yeah.
So as soon as links becomes available, Harshal will send it to you guys.
Yeah, okay, thank you.
This video, right?
Yeah, today's video.
Yeah, I'll send it.
Yeah, no, I'm asking about the Thursday's video, the lab one.
Thursday's video you have.
Oh, I can send you that.
Yeah, okay, thank you so much. Mhm.
I'll send it.